Hi guys, what's up? Hi guys, what's up? Audible हो ना? That's audible, right? Okay. Last time पे आया हूँ. On time today. I'm on time today. Yeah, I'm well. I'm absolutely well. I'm audible, I'm visible, right? I'm audible and visible. And everyone join in and then we'll get started. So you can like the stream if you have just joined. भैया कल आइलैंड वाले क्वेश्चन में अगर प्रिंट करने बोलता तो कैसे करते? Then you have to do a DFS. There is no other option. You have to do a DFS. You have to do a DFS and then you can easily print out. Or probably what you can do is you can take every element and you can simply check if like एक पैरेंट का कौन कौन से है, एक अल्टीमेट पैरेंट कितना अल्टीमेट पैरेंट है तुम रख लेते हैं एंड फिर उस अल्टीमेट पैरेंट का कौन कौन से नोड है वो कर लेते हैं अगर प्रिंट आइलैंड बोलता तो, राइट? लास्ट क्लास फॉर ग्राफ्स here is waiting for everyone to join in. Let's wait for a couple of minutes. We'll start in a couple of minutes. The last lecture for graphs. The last lecture for graphs. Perfect Jeta Chong UN. क्या नाम है भाई? लोगों को लगा नहीं आज मैं टाइम पे आऊँगा. ऐसे लोग आ भी नहीं रहे यार. ये चैनल नोटिफिकेशंस नहीं भेजता यार लोगों को. दिस इज़ वेरी बैड. This is very very bad. Our channel doesn't send notification to anyone. Cool. So for everyone new out here, let me just quickly introduce you myself. My name is Raj Vikramaditya. I'm known as Striver in the programming community. Currently, I'm working as a software engineer. Aware that you can Google and you'll get to know, like not at Google, like you can Google about me and you'll get to know where do I work. And currently, I'm working. Sorry, I'm a content master at Code Forces, also a 6-star coder at CodeChef. I have been teaching from the past couple of years. And I also run a YouTube channel where I have 1 lakh plus subscribers. The channel goes by the name Take You Forward. I also run one more channel which has 40. I don't know. I think I'm not sure how many subscribers do I have. Goes by the name Striver. You check that out too. Subjects that I generally take are competitive programming, DS, Algo, C++, and interview preparation. Okay. Now, if you haven't heard about Relevel, let me tell you about Relevel. So, a lot of times, candidates do miss out on great opportunities due to multiple reasons. One of them being you're from Tier 3, the other being you have less percentage CGPA, while the other being not getting enough opportunities. So this is where Relevel jumps in. So this is a free platform by Unacademy where they have a bunch of companies and you can just go across there and you don't need a degree, you don't need anything, no marks, nothing. If you have a skill, that's absolutely okay. So you can just go over there and you can apply to companies. Now you might be thinking, what is this? So it's basically India's first test hiring platform where they conduct a test which revolves around all the basics of like DS algo, backend like development and all the other things. Now you'll be like, okay, so which companies do hire on the basis of without degree? So generally the companies that hire without a degree are like Cred, Urban Pay, Urban Clap, अभी अर्बन कंपनी है शायद. यहाँ अर्बन कंपनी, कोऑर्डिनेशन, रेजर पे, 1 mg yellow messenger, and I can name like 50 plus companies in इनके platform पे, and there are around 1,000 plus job openings across business development, front end development, back end development. You can attend this test for absolutely free, like कोई पैसे नहीं लगते हैं. You just go and attempt the test and you can finish the test. Once you finish the test, you will get a score, and using that score you can apply to all the companies that are like CureFit भी है, I think Zoomcar भी है, Grow भी है, Upgrad भी है. You can go and apply to all these companies on their particular site. And the three profiles that they generally hire are business development, front end development, and back end development, like 10, 15, and 15 LPA on an average. And you just need to book a slot. And yes, and after that you just need to create a video resume which will go to the recruiter. And yeah, this, what are you waiting for? Just go and register for Relevel today. It's absolutely free. And if you haven't joined the Telegram group yet, please make sure you check out the link in the description and join it as soon as possible. Also, if you're new to this channel, do consider subscribing, click the like button, and yeah, घंटी बजा देना यार, घंटी बजा देना, ठीक है? Perfect. You guys ready? Up? Everyone's ready? Up for class? के लिए ready? Everyone up for the class? Yeah. Yes. So I'll tell you what's on today's itinerary. Basically, I'll start off with something which is known as the probably minimum spanning tree, telling you a bit about what is minimum spanning tree. Then I'll start with something which is known as Kruskal's algo. Okay, and once you're done with Kruskal's algo, we will move to something which is known as bridges in graph, and then we will do Bellman Ford. And once you're done with Bellman Ford, we'll do the alien dictionary problem that was left from the TopoSort class. Cool. So any confusion? So apart from Kruskal's algo, there is one more algo which is known as Prim's algo. You don't need that if you know Kruskal's algo. There's absolutely no need of going across Prim's algo. But even if you still want to go, you can check this out on my channel. You'll get this Prim's algo as well. Bridges in a graph is a very interesting concept. I'll be teaching you bridges in a graph. The other one, obviously, you can check that out. Bellman Ford is again an interesting one. I told you Dijkstra does not work on negative cycles, so this is where Bellman Ford will come in. And alien dictionary is a very good problem which actually tells you about how tough problems can be on TopoSort. Like this alien dictionary will involve every concept of graph, cycle detection, TopoSort, every other thing it will be involving. So this is what will be the itinerary for today. If you have any doubt, you can tell me. The yesterday's class, it's not related to yesterday's class, but yeah, alien dictionary, the last portion is definitely related to something which is the lecture 3. So if you haven't watched the lecture 3, probably will not understand alien dictionary. But before this, nothing is related to the previous class. You can definitely watch it even if you haven't watched the previous class. Just that you should be knowing what is graphs, how to do a DFS in graphs. If you know these two things, graphs and DFS, you can watch this entire stuff. Clear? Any other doubts? Any other doubts? No doubts. Okay, cool. Let's get started. What's a MST? It's generically known as minimum spanning tree. लास्ट क्लास में हमारे पास सिर्फ 40 बंदे बचे हैं. 800 से हमने शुरू किया था. This actually shows that how many people are not willing to learn tough concepts. The moment they find it tough, they don't attend classes. That's why now आप लोग बहुत there's a lot of people who just keep crying out, we don't get opportunities. People सारे courses paid है. People cry out, right? People blame people. So people blame a lot of other stuffs. But again, when someone takes free classes 5-6 days consecutively, I took 6 days. Today is the 6th day consecutively I'm taking a class. I'll look at the response. After this response, just tell me, why will I take a master class? I'll just randomly pick Amazon. I'll give an Amazon tag. I'll do interview experience. People will watch that. This is why not everyone gets to bigger companies. Everyone gets to TCS, but only a limited bunch gets into the bigger companies. This is the only reason. ठीक है? And फिर अभी अगर मैं इधर कहीं पेड में पढ़ाऊंगा तो फिर लोग आके हमें गाली देंगे. But that's if you don't motivate people to teach, why will someone teach for 6 consecutive days if you don't motivate people, right? There has to be a motivation. Abhi wahi main, if I just do a resume review, there'll be 600 plus watching. If I do a resume review. So where will people get motivated? Why will someone teach? People will do a resume review, people will do a live mock coding, people will do these stuffs, right? Because those things give you views. Whereas teaching something like a Dijkstra, DSU, like everyone who has attended yesterday's class, you can ask them if they have any doubt in DSU. DSU मतलब पानी की तरह clear हो गया होगा कल के क्लास के बाद. Everyone who watched it, do you understand that or not? Do you understand? Like DSU clear नहीं हुआ था बताओ कल. That much DSU, two lead code hard problems. Where will you find, man? Where will you find union by rank in everything in 2 hours, along with a debugging wonderful session, right? Cool. Okay, cool. So let's get started. What is the minimum spanning tree? So this is the last set of master classes I'll be taking. After this, I'm not sure what masterclass. Probably I'll just keep on solving random YouTube lead code problems. Cool. Let's get started. So if you have a 0, 1, 3, then we have something like 4, then we have something like 2. So I'm just drawing this graph just for a better representation. 6, the edge weights are 6, 6 to 8. Okay, 5, 3, 7, 5, 3. Okay, this is the example that we'll be dealing with. So I'm given this particular graph. Okay, I'm given this particular graph. Now this graph has, I think, 1, 2, 3, 4, 5, 6. This graph has 5 edges, sorry, 5 nodes and 6 edges. This particular graph has 5 nodes and 6 edges, right? So Abhi, if I convert this into something as a tree, do you remember the property that I told you in the first day? For tree, what should be the property? Do you remember? For tree, what should be the property? The property will be something as n nodes, and instead of 6 edges, it has exactly n minus 1 edges. Remember the property of trees. So whenever you can convert a graph to a tree, this has to be maintained, n nodes and n minus 1 edges. Okay. So Abhi, what's the n nodes and n minus 1 edges? Now in this minimum spanning tree, what's the criteria? The criteria is very simple, right? Convert it into a tree, such that in that tree you can reach any node. That's the main funda. What does that mean? What if I just convert this to something like 0, 1, 3, 4, 2. What I did was I converted this particular graph into something like this, where I can definitely say there are 5 nodes and 1, 2, 3, 4, exactly 4 edges, right? These are the number of nodes and these are the number of edges. Can I definitely say that or not? Right? So this is something which you call as minimum spanning tree. So this is not a minimum, this is something which you call as spanning tree. Spanning tree. Why? Because you see that I removed this one and this one. If you carefully see, I removed this and this. Even after removing this, the entire graph, yes, the entire graph is still connected and it has exactly 4 edges and 5 nodes. So thereby such a thing is known as spanning tree. Okay, so probably I can also create other kind of spanning tree where I say 0, 1, probably I can do it as 4, this can be 2, and I think, do I have anything else? Yeah, this can be 3. This is also spanning tree. So for a particular graph there can be multiple spanning trees. Okay, again you see the entire graph is connected. Right? So do you understand the meaning of spanning tree? Does everyone understand the meaning of spanning tree? Yeah, today is the last session of the graph. Does everyone understand the meaning of spanning tree? Everyone understood? Okay. Now when I say a term like minimum, what does that mean? So what you'll do is, if I just write the edge weights, yes, if I just write the edge weights, this is 2, this is 8, this is 6, this is 5. So the cost will be 2 plus 5, 7, 7 plus 6, 13, 13 plus 8, that's 21. That's the cost of this spanning tree. The cost of the spanning tree is 21. Whereas if I take this, the cost of this spanning tree will be 2, 8, 5, 7, and if I add this up, this will be 22 again. This is 21, this is 22. So if you can form such a tree, yes, if you can form such a tree which has the minimum cost, if you can form such a tree which has the minimum cost, probably over here, like if I just do a drawing over here, and if I try to create the minimum spanning tree, probably I can create 0, 1 and take the edge weight, and then probably I can take 2, and then I can take this guy which is 4, then probably this guy which is 3. I think, yeah, this is the minimum spanning tree. I cannot get anything better than this. Can you get something better than this? At least I cannot see, like यहाँ पे कुछ addition गलत हो गया क्या? At least I cannot see something. At least I cannot see something better than this. So the 6 plus 2, 8 plus 3, 11 plus 5, 16. So this is the minimum spanning tree for this particular graph. This is the minimum spanning tree for this particular graph. Did you understand what is minimum now? You understood spanning? Now whenever you can minimize this cost, whichever tree gives you the minimal cost, that will be the minimum spanning tree. Understood? Understood? Ankit, I'll come to that afterwards. Understood the definition of minimum spanning tree? Everyone? Does everyone understand the minimum spanning tree? Okay. So if you have understood, I'll quickly give you another example. कहाँ है मेरा example? Example लिखा तो कहाँ रख दिया? I'll give you quickly another example, and you need to tell me what's the weight of that. ठीक है? चलो try करते हैं. So I'll give you something like 0 दे देते हैं. 1, 5, 2, 3, 0, 1, 2, 3, 4. This is how it looks, and if I just name it off, 9, 1, 4, 2, 3, 3, 5, 7, 8. So can you tell me the cost of the minimum spanning tree? Like, you can take your time and you can tell me. For this particular graph, what will be the cost of the minimum spanning tree? Can you quickly tell me? क्या cost होगा इसका? Can you just quickly tell me what will be the minimum spanning tree cost for this? हाँ, ग्राफ सीरीज वाला ही है, ग्राफ सीरीज वाला ही है. वो भी देख सकते हो, ये भी देख सकते हो. Someone is saying 20. Okay. Someone said me 20. Someone is saying 15. Someone is saying 17. Okay. Let's see. So something I know for sure is, like, intuitively my brain, let's see how my brain works. Intuitively I will be like, why don't I take the minimum most edge? Intuitively, that is what I will always try to do. So intuitively, I try to take the most minimal edge. Okay, I've taken this. Next, I try to take the second minimum edge. Again, intuitively, I'll do that. Next, intuitively, I'll be like, I'll take the third most guy. So that's this. So I'll take this. Again, I'm doing it intuitively. Next, minimal is this guy. But will I take this? Because they're already connected. Logically, they're already connected. So will it make sense to take this 3? I don't think intuitively that makes sense, because I want to create a tree. And if 1 and 2 are already connected via this path, that doesn't make sense to take this 3. I don't see that. So I will not take this 3. Next is this 4. So I'll take this 4. Next is probably this 7. Sorry. Next is this 5. Again, doesn't make sense to take this. So I'll take this. I think this is the MST. I think this is the MST, if I'm not wrong. Yeah. So 4 1 5 5 2 7 7 3 10 17 is the cost. Did you get the intuition what I was trying to do? I just tried to take up the smaller edges and try to connect them to make a tree. Did you get the intuition? Did you get the intuition? How did I make the minimum spanning tree in logic? आया क्या लॉजिक में? सबको आया? Yeah, there can be multiple MSTs. There can be multiple MSTs. Yeah, absolutely, Rishabh. There can be multiple MSTs. Perfect, guys. So everyone's sure that there can be multiple MSTs, right? Okay, cool. So yes, ultimate parent ka concept. So do you remember the DSU from yesterday's class? So how to find MSTs? There are a couple of algorithms. One of the algorithms is known as the Kruskal's algo. And the other one is the Prim's algo. There's no need to do the Prim's algo. If you want to do it, you can check it out on my channel, but I will highly recommend know just one algo and know it in the best possible way. In an interview, no one is going to tell you, hey, Prim's bata, hey, Kruskal's bata. No, they're going to tell you just find the MST. And if you know it, it's absolutely okay. So the Kruskal's algo. Okay, Shohash, take care. So the Kruskal's algo tells you that, hey, why don't you sort all the edges according to the weight? So it will sort all the edges according to the weight. So the first edge will be 0 to 1 with a weight 1. The next edge that will come across will be 1 to 3 with 2. The next edge that will come across will be 3 to 2 with 3. The next edge will be 1 to 2 with 3. The next edge will be 1 to 5 with 4, whereas the next edge will be 0 to 2 with 5, whereas the next edge will be 3 to 4 with 7, whereas the next edge will be 2 to 4 with 8, the next edge will be 0 to 5 with 9. Okay, so sort all the edges. That's the step 1. Sort all the edges. I'll just write the steps. Sort all edges according to weights. There's no need to form the graph. Remember this. Over here, the forming of graph is not required. If you have the set of edges, you can just sort them according to the corresponding weights. Okay, that's the step 1 that you will do. Okay, so what I've done is I've basically taken 0, 1. That's the first edge. Now, can I say initially, if I apply something like a disjoint set union, where every node is the parent of himself. Do you remember yesterday's concept where I say I start off with n nodes, where I say n nodes, like 0 will be the parent of himself, 1 will be the parent of himself, everyone is the parent of himself. Okay, so अच्छा कॉन्टेस्ट चल रहा है इसीलिए इतनी कम ऑडियंस. कोई नहीं, सह लेंगे क्या ही जा रहा है. 0 to 1 and 1. Okay, so what that apparently means is they are saying ki, okay, there is a 0, there is a 1, so will their ultimate parent be different? I'll be like, yes, absolutely. The ultimate parent of 0 and 1 will be different, which means these two guys are not connected. Hence you will connect them. So let's connect them. So I have connected them. Perfect. You know how to connect? What will you use to connect? क्या करोगे कनेक्ट करने के लिए बताइए. How will you connect them? Yesterday's class क्या? What will you use? Guys? Come on. बता. Union, yeah, perfect. DSU का union is required to connect. Yes, perfect. So everyone understands this. So yeah, so I'll do union. Next, they're saying 1 and 3. Again, if you find 1's ultimate parent, it will be someone else, and 3's ultimate parent will be like both of their ultimate parent. If I say 1 ka ultimate parent and 3 ka ultimate parent, both of the ultimate parent will be different, right? So can I again connect them? Yes, I'll connect them. So I'll connect them, I'll take it. Next is 3, 2. So again, both of their ultimate parent will be different, so I'll take them. Now comes the main question. Whenever you try to figure out 1 and 2's ultimate parent, what will happen? You figure this out that both of their ultimate parents are equal. You figure that out, that both of their ultimate parent are equal. Don't you see that? 1 and 2 are belonging to the same component. So whenever you call the DSC to find the parent, you figure this out, that the ultimate parent of both of them are different. Hence you do not take this. Perfect. Next, 1 and 5. Again you figure this out, that they are different, so you connect them. Next, 0 and 2. So 0 and 2 are actually belonging to the same component. So the ultimate parent will be same. Hence you will say no need to take it. Hence you will say no need to take it. Perfect. Next, 3 and 4. So again 3 and 4 having different, so you will take it. What's the next? 2 and 4? No, because they're already belonging to the same. 0 and 5? No. So can I say, if I sort the edges and if I write the point, U and V can connect and form and be a part of MST and be a part of MST if parent or U parent, ultimate parent of U, is not equal to ultimate parent of V. Do you agree with this or not? After that, union them. After that, do a union for connecting. Is the Kruskal's algorithm right into your head? Is the Kruskal's algo right into your head? Will you ever forget this? Will you ever forget this? Kruskal's algo. Is that right into your head? Is that right into your head? आ गया सबके दिमाग में सीधा? अच्छा इधर से UQ everyone right? वेट तो मिनिमाइज हो जाएगा ना सूरज, अगर लॉजिकली सोचोगे वेट तो मिनिमाइज हो जाएगा, है कि नहीं? क्योंकि तुमने तो यहाँ पे सॉर्ट कर दिया था, तुमने तो यहीं पे सॉर्ट कर दिया था, तो तुमने सिर्फ छोटा छोटा प्लस छोटा प्लस छोटा प्लस छोटा इक्वल टू छोटा, है कि नहीं? छोटा प्लस छोटा इक्वल टू छोटा, है कि नहीं? समझा? ऋषभ बहुत सिंपल है. पहले अपन लोग सॉर्ट कर देंगे अकॉर्डिंग टू वेट्स. Why? Because I want minimum spanning tree. So I'll sort it according to the weights, and then we will try to connect everyone which is possible, right? And we will just keep connecting. Simple as that. ठीक है. छोटा अगर छोटा लोगे, समझ में आएगा? छोटा लोगे तो मिनिमम वेट ही ना बनेगा. If you take छोटा, it will always be minimum weight, isn't it? It will always be minimum weight, guys. Right? Perfect. So everyone has understood this. Absolutely amazing. Super. Yes. नहीं, but अब तुम्हें तो स्पैनिंग ट्री बनाना है ना. Jatin, you have to make a spanning tree, right? So you cannot just pick everyone, because then you'll end up forming a graph, right? Then you'll end up forming a graph, which I definitely don't want, isn't it? Do I want to form a graph? Absolutely not, right? Cool. So if I form this, oh भाई मेरा sublime, रुको. कल वाला sublime text खुल गया. Amazing. So let's do Kruskal's. अरे वो लाइव पढ़ा, मैं लाइव बहुत बेटर पढ़ाता हूँ. आई डोंट टीच, मतलब आई टीच रिकॉर्डिंग ठीक ठाक, बट आई फील आई पर्सनली आई एम अ वेरी गुड teacher at live. That is what I feel. I'm not sure, probably opinions might vary, but yeah, I personally feel I teach a lot better in live. Recording mein there's no one whom you can interact, so you basically teach and just teach, that's it. Why you can interact, you can go slow. Recording में you have to make it like छोटा बनाना पड़ता है, बहुत कुछ है. So assuming all the things are given over here, assuming edges are given over here, assuming a struct of node and the edges are given to you. Okay, so what I can say is I have n nodes and the edges are given to you. So probably I can create a struct of node, and I can say int u v and probably wt, and probably I can keep int, like I can create a constructor. Like I'm a very big fan of constructors. Because like I was not a big fan of classes and all these things, but the more I've started using them, I've understood how easy the code becomes. You should always use them. Okay, so this is how the vector of node edges lies. So what I'll firstly do is I will make sure they are sorted according to, there's no need to form the graph. If you see over here, there's no need to, like, we haven't even formed the graph. We just take the edges and probably I can write a comparator. I can write a comparator, like something like Boolean comparator, and there'll be node like first p1 first, node second, and you can say if first dot wt is second dot wt, then you can return true or else return a false. That's how you can write the comparator. So everything will be sorted according to weights. ठीक है, अपने चाल पे मैं डीपी लाने वाला हूँ. डोंट वरी, आई विल ब्रिंग डीपी. I'm just working on something. Wait, give me some time. I'm working on something which is much bigger than DP, and it's gonna be huge. So I'm working on it. Let me work on that. Once I'm ready with that, then I'll be back making recording videos. आजकल का मेरा रात का टाइम कुछ और चीज में जाता है. मतलब I'm making something which is absolutely huge. So yeah, let me make that. And after that, probably I'll start making the DP series. ठीक है? Don't worry. Probably till Christmas I'll bring that up. If not Diwali. ठीक है? So I've sorted it. Next is to create a DSU. So remember DSU? Yesterday's class, this is how you create DSU. We have already the DSU written, right? You can just copy that. You can just copy that class. Just copy that class. Right? You just copy paste that class. Okay. So I have copied the class. अरे कहाँ चला गया? So इसको नीचे था. If you follow me on Instagram, you have an idea, isn't it? Okay, so if you just have a DSU, right, you can just give the DSU. And now I have the edge weights, right? I have the edge weights. Assume edges to be in one based indexing. Like I'm writing the code for one based, you can modify that because my DSU that I have designed is a one based DSU. Like no, my DSU is thorough, like सारा में काम करेगा. It's one based also. This DSU works for one based as well as zero based because I have started from 0 and I've gone till end, so it works for everything, right? It works for everything, so it's absolutely fine. Okay, cool. DSU, that is what we have as of now. So if you have a DSU, what's the next thing? I just need to iterate, right? So why don't I iterate? So let's iterate on the edges. So probably I can iterate on the edges and I'll be like, and I can say u will be it.u, v will be it.v, and wt will be it.wt. Now what I know is if the find parent of this DSU, how many of you got scared by classes वाला concept इससे पहले, and अब classes better लग रहा है use करने के लिए? How many of you think that? So once you've done this, you can just do an union DSU.union size, and you can just tell u and v to be unioned, and yeah, probably you can just add the costing to WT, and really you can keep the weight cost as 0, and yes, this will be the cost of the minimum spanning tree, and that's how it looks. Okay, has everyone understood this? सबको क्लियर है? सबको क्लियर है? जब तक इनहेरिटेंस नहीं है क्लासेस ठीक है, but yeah, try to use classes because see, if you use classes, like I have the entire thing created already. I just need to create an object of it. That's it, and I can reuse it everywhere. I can reuse it like you're seeing from yesterday. In every code, what I'm doing is I'm just copy pasting and I'm just reusing. I'm not writing the code again and again. I'm just reusing that, right? Sakshi is saying code को summarize कर दो. देखो साक्षी क्या किया? पहले मैंने sort कर दिया edges को, ठीक है? And I've written a comparator. Now what's this comparator based on? This comparator is something which is like if I just copy paste. I'll just copy paste this comparator. So what's this comparator? Sakshi, this comparator is basically ये मेरा क्या हो गया? अब चल रहा है. What is this comparator? The comparator is basically saying ki sorted according to the weights. So I've sorted it according to the weights. If you don't know to write a comparator, you probably can watch one of my C++ STL lectures. You'll get to know. Then I created DSU of n because there are n nodes, right? I created a DSU. After that, I iterate on the edges according to the sorted fashion. And what I do is I say if their ultimate parent are different, like they're not yet connected. So why don't you connect them? So I've connected them and I've taken the cost, and at the end I'll print the cost. Clear? Now, if you want to return the entire MST, if someone is saying if you have to return the entire MST, probably you can create like vector, a node, and something like MST, and over here you can say MST dot push back, and probably you can just push back the IT. So that will also store the entire MST. If you want to store the MST, you can just do a pushback over here that will make sure that the entire, like all the edges that are involved in MST can be easily stored over here because they are getting connected, right? Is that clear to everyone? Is that clear to everyone? Is that clear to everyone? UK from everyone. UK from everyone. Okay, everyone's understood this? Perfect. What's the next stuff that I was talking about? So you're done with MSTs and Kruskals, right? Both of the things are done for today. MSTs and Kruskals. Now let's start with something which is known as bridges in a graph. Okay, we'll start with something which is known as bridges in a graph. So let's get started. This might be a bit confusing. I am warning. This might be a bit confusing, but don't get confused. Just follow me, okay? Bridges in a graph. What is this bridges in a MST स्टोर करने वाला नहीं है? क्यों नहीं है भाई? क्यों नहीं है? MST store तो easy है यार. MST store is very easy, right? These are the edges. The edge is like U and V. U and V is the edge that is being involved. So I just stored that IT, saying that this is involved in my MST. Right? This is involved in my MST. What's the problem? By the way, has everyone understood the MST storage? This is how you say that, okay, these are the IT is the edge that is being stored. Simple as that. Take advice, this series is over. This series is already over. Yeah, I've solved a lot of problems. Okay, bridges in a graph. So I'm gonna do a bridges in a graph. Okay. What's bridges in a graph? Let's first understand what's a bridge. So the definition of bridge says it's an edge. It's an edge on whose removal the graph gets disconnected. Okay, so let me just give you an example. If I draw something like this for an example, so can you tell me over here which are the bridges? Can you tell me over here which are the bridges? What is the definition of a bridge? The definition of a bridge is it is an edge on whose removal the graph gets disconnected. So if I remove this, is the graph getting disconnected? Not sure, right? The graph is not getting disconnected. If I remove this, is the graph getting disconnected? No. If I remove this, is the graph getting disconnected? No. If I remove this, is the graph getting disconnected? No. But the moment I remove this, don't you think the graph gets disconnected? Yes, the graph gets broken down into multiple components, right? So this is what you call as a bridge. So this is what you call as a bridge. So one of the bridges is 4 and 5. Yes, one of the bridges is 4 and 5. So can you tell me what are the other bridges? Yes, this is another bridge. Like if I just remove this guy also, this is another bridge which is 7 and 9. So I also can say 7 and 9 is another bridge, because on the removal of 7 and 9, the graph gets broken down into multiple components. Hence 7 and 9 is also a bridge. Clear ho gaya bridge ka? What's the definition of a bridge? Is that clear? I'll move to the explanation now. Is the definition of a bridge clear? Is the definition of a bridge clear to everyone? What's a bridge and everything? Clear now? Perfect. नहीं ऑड एंड डिग्री वाला नहीं. वैसे मुंबई आउट हो गया क्या? Is मुंबई आउट? आओ हार गया मुंबई को बाहर निकाल दिया किसी ने. कोई बात नहीं. जैसे I'm a new champion. Okay. Cool. So what am I looking for is, टेक एडवाइस को कोई बोल दो क्या डिफरेंस है. Let people answer that. Let people will answer you what's the difference over here and the other one. Okay, so let's understand how to figure out the graph. So there's a concept of, I'll give you the concept. There's a concept of couple of variables. One is the time of insertion. Okay, the other one is the lowest time. Let's first understand both of these concepts, and then I'll tell you how to use them in a graph. So tech advice, what I'll suggest you is, watch my graph series at first, come back over here and watch the problems that I have solved. Okay, what's the problems that I have solved over there? Probably Dijkstra का problem नहीं दिखेगा, मैं solve नहीं किया हूँ. Toposort का problem नहीं solve किया हूँ. DSU का problem नहीं solve किया हूँ. So those are the three important topics. So I have solved a bunch of problems, like 2 or 3 problems from each of the topics here. Okay, so you can watch out the problems here. Okay, cool. So let's understand. So this is when you reach a node for the first time. Reach a node for the first time. Remember this. This is when you reach a node for the first time. Remember this. This is when you reach a node for the first ever time. Okay. What is a low? Low is the minimum time. Minimum time around, remember this, minimum time around all its adjacent nodes apart from parent. Does everyone understand this? Does everyone understand this? Does everyone understand this? I'm saying time of insertion is when you insert, like DFS jab karte ho, when you're visiting that. When I'm saying low, it's saying minimum time across all its adjacent nodes. Minimum, I can say minimum time of insertion. Minimum time of insertion around all its adjacent nodes. Right? Make sense to everyone? Make sense to everyone? Clear hai sabko? ठीक है. अभी let's move across. So you've understood time of insertion. Now I'll take the graph and now I'll explain you. One, let me draw it small so that it fits in a screen. Let's first understand what is time of insertion. Okay, let's first understand what is time of insertion. Let's assume you start the DFS. Let's assume you start the DFS and you say, this is the first time I visit this. This is the second time when I visit this. Okay, or probably to do it in a better way. At time 1 I'm visiting this. At time 2 I'm visiting this. At time 3 I'm visiting this. At time 4 I'm visiting this. So DFS is like this, and then come back, then go. This is how DFS works. Probably it could have been the other way also, but DFS is man ka malik hai. हम लोग let's assume DFS is something like this, and then comes back, and then goes here, then goes here, goes here, and probably goes here, then 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 come back. Understood DFS? What's the time of insertion? Did you understand this? What is the time of insertion? So 4, this will be the 5th time. Assume this is the 6th. Assume this is the 7th. Assume this is the 8th. And then come back, this is the 9th. This is the 10th. This is the 11th. So what I'm saying is visit, 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 visit. Then come back, visit, 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 visit. Then come back, visit, visit, visit. Then come back, come back, come back. Come back, come back, come back, come back. Understood? What is time of insertion? Has everyone understood what is time of insertion? The moment you touch for the first time the node. Clear? Clear about the time of insertion? Is the time of insertion clear? Is the time of insertion clear to everyone out there? That's my question. Is time of insertion clear to everyone out there? Time of insertion का definition clear है? It's very important to understand. The moment you are touching the node in your DFS, the moment you are touching the node in the DFS, सिद्धार्थ एक सिंपल सा टाइम ऑफ इंसर्शन समझ लो. अगर ऐसा होता ग्राफ, अगर तुम्हारा ग्राफ ये होता, ठीक है, इफ योर ग्राफ वुड हैव बीन लाइक दिस, सिद्धार्थ, तुम पहला सेकंड में यहां विजिट करते हैं, सेकंड सेकंड में यहां, थर्ड सेकंड में यहां, फोर्थ सेकंड में यहां, प्रोबेबली फिफ्थ सेकंड में यहां, प्रोबेबली सिक्स सेकंड में यहां, वापस आते सेवेंथ में यहां, एट्थ में यहां, और उल्टा फर्स्ट, सेकंड, थर्ड, फोर्थ, फिफ्थ, सिक्स्थ, वापस वापस, फिर यहां. गॉट इट? ऑर्डर ऑफ डीएफएस इक्वल टू टाइम ऑफ इंसर्शन. गॉट दिस? ऑर्डर ऑफ डीएफएस इज इक्वल टू टाइम ऑफ इंसर्शन. क्लियर है? टाइम ऑफ इंसर्शन इज क्लियर, राइट? टाइम ऑफ इंसर्शन इज क्लियर. नहीं, वापस आने का टाइम इंक्लूड नहीं होता. इट्स टाइम ऑफ इंसर्ट ऑर्डर ऑफ डीएफएस. Okay, so everyone has understood time of insertion. Now it's important to understand the low time. It's important to understand the low time. Okay, so let's understand the low time. So if you're standing here, what is the definition of low? Low says my low will be, if I'm coming like this, for this guy the low will be 9. If I'm coming like this, the low will be 9. Why? It says all my adjacent. So for this guy, apart from the parent, who is the adjacent 9, all my adjacent, उसका minimum insertion, that's 9. Hence, मतलब मैं खड़ा हूं, देखो मैं खड़ा हूं, मैं चारों तरफ देखूंगा सबसे मिनिमल टाइम कौन है, चारों तरफ मैं चारों तरफ देखूंगा सबसे मिनिमल टाइम कौन है, एंड जो है वो मेरा लोएस्ट टाइम बनेगा. समझ में आया लोएस्ट का मतलब? अगर मैं इधर खड़ा हूं, मैं अपने चारों तरफ देखूंगा कौन कौन एडजेसेंट है, पेरेंट को छोड़ के. इस बंदे का पेरेंट ये था, इसको छोड़ दूंगा, इसको छोड़ के चारों तरफ देखा तो सिर्फ 9 दिखा. 9 का इंसर्शन क्या है? 9. तो मैं बोलूंगा भाई मेरा भी 9 है, लोएस्ट टाइम. गॉट दिस? हैव यू अंडरस्टूड द कॉन्सेप्ट ऑफ लो? बेसिकली you stand at a node and you look on all the adjacents and you say what's your minimal time, what's your minimal time, what's your minimal time, what's your minimal time, and among all the minimal times, whichever is the minimal, you'll take that minimal time. So have you understood the concept of low? It's very important to understand the concept of in and low. Have you understood the concept? The more I'll do a dry run, you'll understand. The more I'll do a dry run, you'll understand. आगे सबको समझ? मैं चारों तरफ का बोल रहा हूं, मैं फटाफट इसको मिटा देता हूं. Okay, cool. So everyone has understood the concept of minimal time, right? Yes. Renita has written this. Minimum of adjacent nodes apart from parent. बाप से नहीं, Renita, बाप से नहीं. Minimum of adjacent nodes apart from parent. Okay, now let's understand. And remember one more thing, खुद का भी ले लेगा वो, खुद का भी इंसर्शन टाइम लेगा, एडजेसेंट का लेगा. सो इन शॉर्ट इफ आई राइट, लो इज मिनिमल ऑफ एडजेसेंट कॉमा हिमसेल्फ, राइट, अपार्ट फ्रॉम पैरेंट. ओके, Now let's get started about the concept. So what I will say is I need to figure out the bridges, right? I need to figure out the bridges. So time of insertion 1. So I'll try to write like this: time of insertion and time of low time, the minimal time. So the time of low is also 1 because that's the minimal he has as of now. He has not looked around its edges. He has not looked around its adjacents. So the minimal that he has is 1. Okay. Next. He still has a minimal of 2. Next. He still has a minimal of 3 because he hasn't looked around yet. You look around when you come back. When you come back. Why? Why? Because DFS में तुम अंदर जाओगे नहीं तो एडजेसेंट का टाइम कैलकुलेट होगा कैसे? जब हो जाएगा वापस आओगे तब अपडेट वापस एडजेसेंट से करवा लेंगे. आया? अभी और भी आएगा समझ में. 4 4 5 5. So in order to understand this better, let's do it on the right half. 6 6 7 7. This will be 8 comma what? You will say me. 8 comma क्या होगा? You will say me. क्या होगा? तुम लोग मेरे को बताओगे 8 comma क्या होगा? You will say me. What will be the lowest time? You will say me, not I. What will be the lowest time? Tell me. This is the parent. Forget this. What's the lowest time? You will tell me. बताओ. What's the lowest time? Tell me, tell me, tell me. Yes, yes, yes. 5, 5, 5. 5, not 6, 5. इन भाई साहब का एडजेसेंट कौन है? ये और ये. दिस इज पैरेंट, नॉट टू बी कनेक्टेड. दिस इज पैरेंट. अपार्ट फ्रॉम पैरेंट हु इज द एडजेसेंट? 5. सो इन हियर व्हाट्स द लोएस्ट? 5 and 5 में लोएस्ट कौन है? सबसे छोटा 5. सो यू विल से 5 is my lower time. You will say 5 is my lower time. You look across adjacents. And you will say 5 is my lower time. Does that makes absolute sense? Yes, it does, right? Now, it's a time to go back. It's the time to go back because there are no further adjacent nodes. So it's time to go back. So what you will do is, when you try to go back, remember this. When you try to go back, this is when you go back, right? Now, this 7 will say, now tell me, ये 7 का adjacent क्या होगा? मेरे को बताना क्या होगा? इस 7 का लो क्या होगा? 7 ही रहेगा या फिर बदल जाएगा? What will happen when you come back? Because see, you were like this and you went, now you came back. So this 7 slow, what will it be now? For this 7 slow, what will it be now? अभी 4 में वापस नहीं गया 4 में. संदेश, I have came here like this. I haven't went back. I have not gone back. When you're going back, you need to update. Yes, this will get updated to 5. No, 5. Remember, how did you come? See, ऐसा है तुम. ठीक है? इस बंदा के लिए ये पेरेंट है. सो ये तो देखना ही नहीं है. इस बंदे के लिए एडजेसेंट कौन है? ये और ये. इनमें से मिनिमल कौन सा है? 8 और 5 में 5 ले लिया मैंने. अब इसका अब जब आएगा तब लेंगे. तो 5 अगेन रिपीटिंग. कम हियर, राइट? दिस इज द पैरेंट नॉट टू बी कंसिडर्ड. गो get this value. When you come back, you have a 5. Why? Because this guy is 5. So you update this. Adjacent. Got this? Now, careful question. When you're coming back from 7, when you came back, because 7 would have called the DFS of 6, went and now comes back. A critical question. Can 7 6 be a bridge? Can 7 6 be a bridge? That's my question to you. Can 7 6 be a bridge? The answer to that will be no. Why? Because logically, let's understand. If I eliminate this, you still have a minimal time of 5, which means इसका इंसर्शन 8 था. तुम्हारे पास 5 है. तुम वापस घूम के इस तरफ पहुंच सकते हो. समझो, you can still reach here. You need to understand this. You can still reach here. Got this? Why? Because why does this have a 5? Why does this have a 5? You need to understand why. Because ये 7 जो है ना, देखो तुम ऐसे आए, यहां गए, अब जो वापस जाना है, तुम पूछ रहे हो 6-7 क्या एक ब्रिज है? इज दैट अ ब्रिज? इज 6-7 a bridge? I'll be like, no. Why? Because the 6 can reach 5. If it can reach 5, which apparently means it can reach somewhere before 7. Hence, it can take this path and still can reach 7. It can take this path and still can reach 7. Do you understand? What's the intuition? इस 6 में 5 का मतलब क्या है? मतलब ये यहां पहुंच सकता है, अगर 5 में पहुंच सकता है तो इस जरिया से ये 7 में भी तो पहुंच सकता है. तो ये ब्रिज तुम हटा देने से भी स्टिल दे आर कनेक्टेड, दे आर स्टिल कनेक्टेड. डिड यू अंडरस्टैंड द सिग्निफिकेंस? डिड यू अंडरस्टैंड द सिग्निफिकेंस ऑफ time of insertion and low? Did you understand the significance of time of insertion and low? Yes or no? I'll repeat. Now when you come back, ये जो 6 है, ये बोलेगा क्या मैं ब्रिज हूं? Is that a bridge? Right? So you'll be like, इसका टाइम 7 है, इसका टाइम 8 है. क्या ये 8 का बंदा ये 7 में पहुंच पाएगा अगर मैं ये हटा दूं? फिर बता रहा हूं. क्या ये 6 का बंदा, क्या ये 6 7 में पहुंच पाएगा अगर मैं ये ब्रिज हटा दूं? मैं बोलूंगा हाँ भाई, मेरे पास तो 5 है. 5 का मतलब है कोई है जो 7 से भी पहले आता था, कोई है जो 7 से भी पहले आता था. हेंस मैं भाई उस रास्ते से चला जाऊंगा और पहुंच जाऊंगा. तुम इसको हटा भी दो तो ये तो ब्रिज नहीं है. समझ में आया? अब आया समझ? आई थिंक दिस शुड बी क्लियर नाउ. 6 बोला मेरे पास 5 है, मतलब मैं 7 से पहले पहुंच सकता हूं इस जरिया से, क्योंकि मेरे पास 5 है, मैं पहुंच सकता हूं वहां वापस. सो कैन आई से इफ दिस एडजेसेंट हैज अ लो टाइम, if this adjacent has a low time, like this is the adjacent, if that low time is lesser than time of insertion of the current node, because I was standing at this node, this is the adjacent. So if this time is lesser than this 7, can I say दूसरा रास्ता से पहुंच जाएगा? Got it? क्योंकि ये जो टाइम है इसका बोले तो ये 7 से पहले पहुंच सकता है, तो ये दूसरा रास्ता ले लेगा. आया समझ? If this is the case or lesser than equal to for that case, I can say it can still reach. Got it? Okay, when we move forward, you'll understand. देखो, अब तुम इधर थे 8 पे, तो इधर आओगे तो टाइम क्या होगा? 9 क्रॉस 9, मूव अहेड 10 क्रॉस 10, मूव अहेड 11/11. But you find this guy already visited. Now you're like this is already visited. So what will this 11 do? What will be the value of 11? Tell me what will be the value of this low. What will be the value of this low? Everyone, what will be the value of this low? I'll give you one more repeat. Don't worry. What will be the value of this low? What will be the value of this low? Can you tell me? 9. Yes. It will be 9. It will be 9. So what does that mean? Now imagine you went like this. Now you came back. So this is your node now and this is your adjacent. Now can I say इसका समय 10 था और ये बंदा बोलता है ओ भाई सुन, मैं दूसरा रास्ता से 9 में पहुंच जाऊंगा. तो अगर 9 में पहुंच जाओगे तो तुम 10 में भी तो पहुंच सकते हो, क्योंकि 9 से ही तो 10 जाएगा, क्योंकि 9 से ही तो 10 में पहुंचोगे, है कि नहीं? क्योंकि 9 से ही तो 10 में पहुंचोगे, है कि नहीं? Got it? Got this? Hence this also is not a bridge, because the moment you are saying that is 11:10 a bridge, 11 says hey dude my time is 10 but this guy's time is 9, ये दूसरे रास्ते से पहुंच जाएगा, तो ये ब्रिज नहीं हो सकता. This cannot be a bridge. Perfect. Now tell me, when it went like this and now it came back, so what will this 10, ये 10 को क्या होगा? ये 10 क्या हो जाएगा? बताओ, ये 10 क्या हो जाएगा? 10 slash 9. 10 slash 9, right? Because it will take the adjacent. For 11, this is the adjacent, not this. This is the adjacent. Because this is the parent. This is the parent. So this is the adjacent. So it takes 9. Understood? So 11 slash 9. Now you'll go back. That came back like this. Went. Now it will go back. Now I'm at 9. I'm at 9. So now this 9 says, is this a bridge? Is this a bridge? 10 बोला. 10 बोला. तेरा 9 है ना? अरे मैं तो पहुंच रहा हूं वापस तेरे पास. मैं तो वापस इस जरिए से पहुंच जाऊंगा तेरे पास. Let's understand again. You came here like this. When you went back, you checked for this bridge. Now you're going back, you'll check for this bridge. There is a 9. And this guy is also saying 9. But whereas, ये जो लो है, इसने ये बंदा इधर से बोरो किया है. इधर से नहीं, इधर से बोरो किया है. इसका मतलब है तुम इसको भी हटा दोगे ना, ये इधर से पहुंच जाएगा. समझ में आया? This is also not a bridge. So this is also not a bridge. Perfect. Now it will go back. And when it goes back, we have a 7 and we have this. Now comes the main funda. This guy says, मेरा insertion time 7 है. ये बोलता है, मैं at max 9 पे ही जा पाऊंगा. 9 से छोटा मैं जा नहीं सकता. मैं जा नहीं सकता 9 से छोटा. तो इसका मतलब क्या है? कौन bridge है? That means 7, 9 is a bridge. Why? For 7, it's 7. But 9 says मैं 9 से छोटा जा ही नहीं सकता. Possible ही नहीं है. It's not possible that I can go lesser than 7. Lesser than 7 is not possible. Hence I'll say 7, 9 is a bridge. Understood everyone? Does everyone understand this? Clear है? Is that clear? Clear है सबको? Is that clear why 7, 9 is a bridge? इसका देख recap पूरा मार देंगे समझ में आ जाएगा. Is that clear to everyone? It's a bit confusing, I know. I also got confused when I first studied this. मतलब if you just want मैं फॉर्मूला से रटा देता, बट वो इंट्यूशन नहीं आएगा. मतलब इंट्यूशन नहीं आएगा, इसलिए मैं रटा नहीं रहा हूं. क्लियर हुआ क्या? Yes. Yes. Yes, you check for load time and insertion time. Basically, if you are at a node, you say this is my time of insertion. This is the adjacent node. It's a slow time. Which means this slow time, देखो, slowly बता रहा हूं, देखो. ये नोड है, इसका टाइम ऑफ इंसर्शन 1 है, ठीक है. और ये एडजेसेंट नोड है, इसका लो टाइम है. लो का मतलब क्या है? लो का मतलब क्या है? लो का मतलब है बगल वाले बिना इसके, बगल वाले इसके. तो अगर मैं इस ग्राफ को हटा देता हूं, इस एज को हटा देता हूं, एंड तब भी जो लो वाला बंदा है ये इससे छोटा होता है, इससे छोटा होता है. इसका मतलब क्या है? इसको हटाने के बावजूद ये कोई बगल वाले से एक छोटा टाइम ले पा रहा है, एक छोटा टाइम ले पा रहा है. इसका मतलब है बगल वाला कहीं ना कहीं पीछे से कनेक्टेड था. आया लॉजिक? आया इंट्यूशन? आया? क्यों कर रहे हैं हम? क्यों मैं बोल रहा हूं अगर लो छोटा है तो ब्रिज नहीं है, एंड अगर लो बड़ा है तो कभी पहुंच नहीं सकते. आया लॉजिक? गॉट दिस? नाउ clear? Intuition. That's the intuition. That's a simple enough intuition. क्योंकि ये नोड है, इसका एक टाइम ऑफ इंसर्शन था, इस बंदे का लो टाइम का बोले तो क्या है? इसको छोड़ के बाकी का, इसका छोड़ का बाकी का. तो अगर ये लो टाइम इससे छोटा है तो मतलब कहीं से मैं घूम के पहुंचा हूं, कहीं से मैं घूम के पहुंचा हूं. समझ रहे हो? इंट्यूशन. गॉट इट? अब समझ में आ गया होगा. अब नहीं आया तो मैं कुछ नहीं कर सकता. अब देखो, ये तुम अब इधर थे, अब पीछे गए हो, तो ये क्या होगा? 6,6 क्या हो जाएगा? What will 6 by 6 be? Because now you are like this. Now you'll go back. So what will 6 by 6 be? What will happen to 6 by 6? Now this is your node. This is your node. So 6 by 6 will say, let's first update this to 5 because I'll take it from the, क्योंकि इसके लिए तो ये एडजेसेंट है ना, ये पेरेंट है, ये एडजेसेंट है, तो इससे 5 ले लेते हैं. ठीक है. अब क्या ये बन सकता है? पहला बताओ, ये बन सकता है क्या? ये बन सकता है क्या? नहीं. क्यों? ये 6 है और ये 5 है, तो मतलब ये कहीं से घूम के पहुंच गया. देखा लॉजिक? 6 है तो 5 है, इसको हटा दो, बट ये कहीं से तो घूम के पहुंच गया, तो ये भी नहीं हो सकता. नेक्स्ट, व्हेन यू गो बैक, दिस इज स्टिल 5,5. दिस इज स्टिल 5,5. अगर मैं इसको हटाता हूं, इसको हटाता हूं, तो ये 5 है, ये भी 5 है, तो ये भी कहीं से घूम के पहुंच गया. राइट? नाउ लेट्स गो बैक. द मोमेंट यू गो बैक, this is 4,4 and this is 5,5. So if you remove this, it cannot go back to 4. It cannot go back to 4. Hence, this is a bridge. Hence this is a bridge. Got this? Clear है? Have you got this? Got this? Yes or no? Okay, now you had 4,4. Okay, you had 4,4. Abhi for 4,4, if you remember, you came like this. You came like this. If you remember, you came like this. For 4,4, you came like this. So for 4,4, who are the adjacents? This and this. Whereas this is the parent. So instead of 4,4, what will happen? Instead of 4,4, what will happen? Instead of 4,4, what will happen? बता पाओगे क्या होगा? I'm going very slow, but I'm trying to give you the entire intuition. मैं रटवाना नहीं चाहता हूँ. मैं बार बार बोल रहा हूँ, मैं रटवाना नहीं चाहता हूँ. क्योंकि इफ यू सी जेनीज लेक्चर, यू सी एवरी अदर, वो रटवा देते हैं. कोई इंट्यूशन आपको नहीं बताता है. 4/1, या इट्स वेरी इंपॉर्टेंट टू गिव द इंट्यूशन. दैट इज व्हाट आई एम ट्राइंग टू गिव. दैट्स इट. ओके, नाउ कैन दिस बी अ ब्रिज? यू बी लाइक इसका 3 है बट ये एक में पहुंच जाएगा. अरे भाई घूम के पहुंच जाएगा. नहीं, इसका क्या होगा? इस बंदे के लिए ये एडजेसेंट है तो ये 1 ले लेगा. अब ये फिर बोलेगा कि ये ब्रिज नहीं हो सकता, इसका 2 है, ये तो 1 है. फिर वापस जाएगा. और जो वापस जाएगा, इस बंदे के लिए ये पेरेंट है, ये एडजेसेंट है तो ये 1 ले लेगा. फिर वापस जाएगा तो नहीं. तो अल्टीमेटली डिड यू अंडरस्टैंड हाउ दिस वर्कड? लेट्स डू अ क्विक रिवीजन सो दैट इट गेट्स स्ट्रेट इनटू योर हेड, राइट? अभी तक कितने लोग को पूरा क्लियर समझ में आ गया? मैं रिवीजन दूंगा बट स्टिल, हाउ इफ यू गॉट इट कंप्लीटली? Clear? Okay. Now what I'll do is I'll try to again do a complete super quick. ठीक है, सबको आगे? बढ़िया. क्रिस्टल क्लियर. ओके, मैं इंट्यूशन बता देता हूं, फिर मैं एक बार वापस वो कर दूंगा. ठीक है, you will see a lot of lectures but I did not find the intuition being taught. So मतलब पता नहीं इंट्यूशन किसी ने पढ़ाया कि नहीं. देखो, फंडा क्या है? नोड है, अगर ये पेरेंट है, इसका एडजेसेंट ये है. ठीक है, तो मैं क्या करता हूं, इसको छोड़ के इसका लो निकाल लेता हूं, मतलब दूसरों बंदों का, और मैं बोलता हूं इसका टाइम ऑफ इंसर्शन. अब अगर इसका लो कहीं ना कहीं इससे छोटा आ गया, इसका मतलब क्या, कहीं ना कहीं तो घूम के ये पहुंच ही रहा है इसके पास. नहीं तो ये लो छोटा कैसे आया? क्योंकि टाइम तो बढ़ रहा है, मैं जब राइट में जा रहा हूं टाइम तो बढ़ रहा है, तो ये लो छोटा कैसे है? इसका मतलब कहीं ना कहीं पीछे से कनेक्टेड है, इसी की वजह से ये लो इसको मिला है छोटा. बस यही लॉजिक है. This took me a lot of time. मैं जब इंटरव्यूज में जाता था इनिशियली तो मैं ये रट के जाता था. फिर धीरे धीरे when I got experienced into teaching, then I started thinking of intuition. That is when I understood this entirely. It took me a lot of time. I'll be very honest. It took me a lot of time because कोई समझाने वाला नहीं था. And like honestly, you go back and तुम lectures देखना, तुम्हें लोग बोल देंगे कि भाई ये कंडीशन लिख दो. तुम्हें हर एक लेक्चर में बोल देंगे ये कंडीशन लिख दो, कर दो, बट कोई बोलेगा नहीं क्यों हो रहा है. That's very important. Okay. Now let's quickly do a recap. I am doing a recap because it's kind of I know it's kind of let's do it. 1/1, 2/2, 3/3, 4/4, 5/5, 6/6, 7/7, 8/8. But this 8 says, ओ भाई मेरा एडजेसेंट कौन है? ये बोलेगा 5 है मेरा एडजेसेंट. इस एडजेसेंट का लो कितना है? 5. तो मैं बोलूंगा भाई चलना, दे दे मुझे, ले लिया. अब मैं बोलूंगा मैं नोड हूं, ये मेरा एडजेसेंट है, क्या तुम ब्रिज है? वो बोलेगा ओ भाई सुन, मेरे पास 5 है, मैं घूम के पहुंच जाऊंगा तेरे पास, ये तो ब्रिज नहीं है. मैं बोलूंगा ठीक है भाई, मैं ब्रिज नहीं, चलो वापस. अब मैं नोड हूं, अब मैं एडजेसेंट हूं, पहले तो भाई इसका 5 ले लो. अब मैं नोड हूं, अब मैं एडजेसेंट हूं. मैं बोलूंगा क्या तू ब्रिज है? आर यू अ ब्रिज? एंड वो बोलेगा नहीं भाई मेरे पास 5 है, तेरा तो इंसर्शन टाइम 7 है, मैं घूम के आ जाऊंगा तेरे पास. बोला ठीक है, ये भी ब्रिज नहीं है, दिस इज नॉट अ ब्रिज. परफेक्ट, लेट्स मूव. 9/9, 10/10, 11/11. नाउ दिस इज द नोड, This is the adjacent. So what I'll say is 11. Oh bhai 9 le, chal 9 le. Next, this is the node, this is the adjacent. So I'm saying hey 9, तू तो 9 है, मेरे पास भी 9 है, मैं पहुंच जाऊंगा तेरे पास, तू इसको हटा भी देगा तो इसको हटा दे तो भी मैं पहुंच जाऊंगा. Not a bridge. Next, now this is the node, this is the adjacent, because I'm coming back in the DFS. I'm coming back in the DFS, right? I'm coming back in the DFS. So I'll say this first तो ये ले ले. अब क्या तू ब्रिज है? Node adjacent. तेरा मेरा इंसर्शन टाइम 10 है, तेरे पास 9 है, मतलब तू घूम के आ जाएगा, तो ये ब्रिज नहीं है. परफेक्ट. नाउ दिस इज द नोड, दिस इज द एडजेसेंट, बिकॉज आई एम गोइंग बैक. सेल से दोनों का 9 9 है, ये भी ब्रिज नहीं है. नाउ दिस इज द नोड, दिस इज द एडजेसेंट. पहले तो भाई इसका 9 है, इसका 7 है, तो ये ब्रिज है. व्हाई? बिकॉज इट कैन नॉट रोल बैक. गॉट इट? बिकॉज दिस इज द नोड, this is the adjacent, this is having a 9, this is having a 7, you cannot roll back, so this is a bridge. Now when you go back, this is a node, this is an adjacent. So पहले तो अपडेट कर लो, 5 को ले लो. node adjacent, so 5 6 पहुंच जाओगे घूम के. Same, keep on updating. 5 घूम के पहुंच जाओगे. 4 5 cannot, so bridge. क्लियर हो गया कॉन्सेप्ट? अब तो घुस गया होगा, अब तो पूरा बैठ गया होगा दिमाग में, राइट? It's nice to be right. My watch also says that. Okay, clear? हाँ, थक गया मैं, इतना एनर्जी. LC 1569, LC बाद में देखेंगे भाई, बहुत कुछ पढ़ाना है आज, लास्ट ही दिन है, मेरे पास और घंटे नहीं है इसके बाद. Okay, now we'll code this. It's an interesting one to code. So I'll say a time of insertion, probably I can keep it an array. I can say low time, I'll probably also keep it this an array. And I can say timer, probably I can keep a timer equal to 0. And I'll write void dfs int node int parent, and I'll say time of insertion initially low time of node is equal to timer plus plus. So initially I've just taken a timer and I've said but take one more. कहाँ से लाऊं? इंसान हूँ भाई. You know, from when I'm teaching, last Friday I've started teaching. Friday I taught, Saturday I taught, Sunday I taught, Monday I taught, Wednesday I took 2 classes, Thursday I taught, today is Friday, tomorrow I have 1 more, Sunday I have 1 more. 8 days consecutively I'm teaching around 2 hours, and class के लिए 1 घंटा prepare भी करना पड़ता है. So auto adjacent node of adj of node. So this is the adjacent node. Now we know one thing for sure, if this adjacent node is equal to parent, then we don't need to do anything. There's absolutely no need to do anything. And we know one thing, like we definitely use a visited in DFS. Well, you can use a visited also. So if visited of node is 1, okay. So if not visited, that means we haven't visited. First to call the DFS and node. First call the DFS. When you come back, that's when the funda starts. When you come back, that's when the funda starts, isn't it? When you've came back, it's very important to say, hey, listen, my low will be minimum of whatever I had before, comma your. तेरा भाई तेरा दे, चल तेरा दे, तूने कितना लेके आया? अग्रीड? चल तेरा दे, तूने कितना लेके आया? ये एग्री करते हो? I came back, I say, चल तेरा दे, तूने कितना लेके आया? राइट? ले लिया मैंने. अब मैं बोलूंगा, ओ भाई सुन, हे लिसन, मेरा टाइम ऑफ इंसर्शन is it, or I can say तेरा low of adjacent node, is it somewhere greater than time of insertion of me, which means you can never reach me back. क्योंकि तू तो गया था, तुझे कोई नहीं मिला. You went ना, hey adjacent, You went now. You did not get a low which is smaller than or equal to time. Hence you are a bridge. Hence the bridge exists between IT and node. Agreed? Does everyone agree on this? Does everyone agree on this? I computed the adjacent node and उसका जो भी है मैंने अपने पास ले लिया क्योंकि अपने पास तो लेना ही था. एंड मैं बोला मेरा जो टाइम ऑफ इंसर्शन है बगल वाला क्या तेरे पास बेटर है? अगर नहीं है तो तू वापस तो घूम के नहीं आ सकता. तो मैं ब्रिज हूं. इफ यू डोंट हैव अ बेटर लोअर टाइम ऑफ इंसर्शन, बेटर लोअर, तू वापस घूम के मेरे पास तो नहीं आ सकता. दैट मीन्स यू आर अ ब्रिज. ओके, व्हाट इफ इट्स एल्स? दैट मीन्स it's visited, it's already visited. So on that case, what will you do if it's already visited? If it's already visited, what will you do? And tell me what will you do if it's already visited? If that's already visited, there's no need to do anything. Just take it slow. Just take it slow. Let's take it slow. Take it slow. So low of node will be minimum of low of current node and low of adjacent node. That's it. Let's do this. Let's take it slow. Low of current node minus adjacent node. यही कर लो, काफी है. Is that clear? You don't need to check for here. There's no need to check for it. There's no need to check for it. The reason I'll tell you why there is no need to check for it, because if it's already visited, तो मतलब पहले के जर्नी में विजिटेड, मतलब क्यों चेक करना है? लॉजिकली सोचो. यहां में why did I not do a check? Can you tell me why did I not do a check like this over here? पहले से विजिटेड है यार, पहले के जर्नी में विजिट होके आया हुआ है, मतलब ये साइकिल पहले है ये, तो ये ब्रिज नहीं हो सकता. There's no need to do it. पैरेंट चेक तो इधर है. Why did I not do a check for this adjacent node? Why did I not do a check for this adjacent node? It's very easy to understand. I'll just give you. See, क्यों नहीं किया मैंने चेक? क्योंकि देखो, जब तुम इधर थे, इसका मतलब तुम 9 को विजिट करके ही तो आए हो. तभी 11 बोला कि 9 ऑलरेडी विजिटेड है. 11 बोला 9 ऑलरेडी विजिटेड है. तो इसका मतलब है भाई पहले से आया है, तो इसको हटा के भी कोई फायदा नहीं है. पहले से वो विजिट होके आया है, तो पहले से अगर कोई विजिट होके आया तो वो ब्रिज तो बन ही नहीं सकता. कैन इट बी अ ब्रिज? कैन इट बी अ ब्रिज इफ इट्स ऑलरेडी प्रीवियसली विजिटेड? दैट मीन्स वो पहले से आया है विजिट होके. दैट मीन्स वो पहले से आया है विजिट होके. ये है, तो इसको तुम हटा भी दोगे तो पहले से तो जुड़ा हुआ है, पहले से तो जुड़ा ही हुआ है. गॉट इट? हैव यू अंडरस्टूड दिस? Have you got it? Yes. Yes. Yeah. The example of the else will be whenever you are at 11, 9 is already visited. Whenever you are at 11, 9 is already visited. So even if you remove this, you already came from 9. So that's already connected. How will it become disconnected? Understood? Yeah. Is the code clear? If I give you a repeat of the code, whenever I insert, the time of insertion and lower time will be same. I'll mark it as visited. Then if it is parent, no need to do a DFS or no need to update. Parent पे कुछ नहीं करना है. भाई पे जाके घूम के आते हैं. घूम के आ गया तो उसका लोअर ले ले भाई. चल दे तेरा लोअर दे. तूने कितना लो लेके आया दे दे मुझे. मैं बोलूंगा चल तूने जो भी लो लेके आया, क्या वो मेरे से बड़ा है? मतलब तू वापस मेरे पास तो नहीं आ सकता. तो मतलब तू ब्रिज है. एंड अगर तू पहले से विजिटेड है, तू तो ब्रिज नहीं हो सकता, क्योंकि मैं होके गया हूं तेरे से. मैं होके गया हूं तेरे से, वापस पहुंच गया, तो तू ब्रिज नहीं हो सकता. चल कोई बात नहीं, तू अपना लो दे दे बस. गॉट इट? I need a UK from everyone. I took a lot of effort to teach this. I need a UK from everyone. It took me 25 minutes. But I am very much sure, I'm very much sure this is crystal clear to everyone. This is right into your head. I'll not forget this forever, right? Okay. Bridges in a graph. Decode it, right? So anyone tells you about bridges in a graph, do tell him ये वाला वीडियो देख लो. क्रॉस एज का कॉन्सेप्ट मैं नहीं लाता दिमाग में, वो बहुत कंफ्यूजिंग होता है. आई डोंट ब्रिंग साहिल क्रॉस एज. I keep it like this. I keep it very simple, intuitive. People generally bring cross edge and all these concepts to basically see कि मतलब क्या होता है ना, मतलब बहुत लोग इंट्यूशन नहीं सोचते हैं, वो लोग कुछ कॉन्सेप्ट लेके बोलते हैं ये कॉन्सेप्ट है तो ये कर लेना. अरे भाई क्यों कर लेना, कोई बोलना ही नहीं चाहता है, प्रॉब्लम इधर है. Okay, cool. So we have understood this. Another concept clear, bridges. There is one more concept which is known as articulation point. Again, you can watch that on my channel. If you are articulation point मेरे channel पे देख लेना, ठीक है. मेरा पेटीएम किसने यूज कर लिया भाई? पढ़ाता हूँ, पेटीएम से पैसे कट जा रहे हैं तो हद है. Okay, cool. So everyone has understood this. Amazing. So what's the next thing that we are left with? एक second, हाँ. Hello. Yeah, sorry. Okay. So, okay, we have understood this. Okay, so next one, Bellman Ford. So, shortest path. So, a lot of times there might be cycles. Bellman Ford algo. It's known as the BF algo or Bellman Ford. Okay. So generally, if there are negative edges, then Dijkstra doesn't work. If there is a negative cycle and a negative edge, or a negative edge, something like Dijkstra does not work. Even Bellman Ford doesn't work, but Bellman Ford will tell you the answer. But Bellman Ford will tell you that there is a negative cycle and a negative edge or whatever it is. Why? Let's understand. If I'm saying there is an edge between 1 to 2 and it's -2, which apparently means there is a bidirectional edge. Hence, I can, from 1 to 2, if I go, that will be -2. Again, if I come back, this will be -4. Again, if I go, this will be -6. Again, if I come back, this will be -8. So don't you think every time I shuffle across, the distance will get reduced? And we cannot use that in Dijkstra. If you remember, the Dijkstra clearly stated, if distance of current node plus the weight is lesser than distance of the adjacent node, then you keep on updating and putting it into the PQ. Remember this condition? याद है क्या ये कंडीशन? Okay, Scary Con, bye bye. Do you remember this condition? Yeah, infinite loop. So the Dijkstra will end up being in an infinite loop, because every time you add in weight, he'll get reduced. So that's why something like a Dijkstra does not work in a negative cycle or negative edge, and it's practically impossible to figure out what's the minimal edge. Got this point? But if Dijkstra falls under infinite loop, so how do you detect? What if there's given a question where they say there might be positive edges, there might be negative edges. If there is no negative edges, give us the shortest path. If there is a negative edge, tell us that there is. How will you do that? That is when a shortest path comes in. Sorry, Bellman Ford comes in. So there is a scientist who is known as Bellman Ford, and Bellman Ford says, I will apply compression technique n minus 1 times. I'll apply compression techniques n minus 1 time. What is a compression technique? What is a compression technique? The compression technique states the distance, like if there is an edge between UVW, if there is an edge between UVW, the compression technique states I will do distance of U plus WT lesser than distance of V. This is what the compression is. I'll tell you why and everything. Distance of V equal to distance of U plus WT. I will keep on doing this compression technique, yes, for n minus 1 times. And once I've done this, I will always have the shortest distance. Once I've done this, I'll always have the shortest distance. You might be thinking, how's it possible even, Raj? You might be thinking that, right? How's it even possible? It will be great if you shorten the face cam part to the bottom right corner and the rest contain as the, that's not allowed here. I'm not sure. Basically what happens is if I keep my face smaller, YouTube does not specifically promotes those kind of content where there is a lack of person in it. So YouTube does not promotes. If I keep a face like small, YouTube will not promote that. Generally, if you see my take you forward videos, also YouTube does not pushes that much. It's more of good mouth के वजह से जो लोग देखते हैं, किसी ने इसको बोला, किसने उसको बोला, LinkedIn पे लोग पोस्ट देख के देखते हैं, वरना मेरे वीडियोस रेकमेंड नहीं होते टेक यू फॉरवर्ड पे, क्योंकि मेरा फेस ही नहीं है. That's why they have came up with this concept of having a bigger face, so that YouTube algorithm figures out that okay, this video has a face, so it's a genuine video. Let's push that across. Got it? Okay. Cool. So everyone's understood this. This is the compression technique. Now, why is this compression technique done n minus 1 times, or how is this compression technique working? Because if you do this, this is something we did in Dijkstra. Remember, this is something we did in Dijkstra. याद है क्या? Dijkstra में ये किया था? याद है क्या? Dijkstra में ये किया था? किसी को याद है Dijkstra में? This is what we did. Do you remember? Do you remember? Do you remember? In Dijkstra we did this. Yeah. So why on earth, if I do this for n minus 1 times, this will work? Why on earth, if I do this for n minus 1 times and repetitive, will this work? Any reason? Any reason why will this work? Anyone? Let me just give you an easy linear graph so that you can understand. Let me give you a very easy linear graph. Okay. 0 connected to 1 with 2, 1 connected with 2 with 1, connected to 3 with 2, and connected with 4 with and probably 1. Okay, this is what it is connected. What I will keep initially is everything to be infinity. Okay, everything to be infinity. So this is the linear graph that I've taken, linear graph, and this is what I've kept. So what I'll do is I'll have all the edges, and assuming the worst ordering is given, which is at first the last edge is given 3 4 1, then 2 3 2 is given, then 1 2 1 is given, then 0 1 2 is given. Okay, this is what is given to us. So apparently what I do is I apply a distance of U plus WT is equal to distance of V, then I will do distance of V equal to distance of, intuition खुद ही आ जाएगा जब मैं इसका ड्राई रन करूंगा, don't worry, intuition will come automatically. You need to do this across all these things n minus 1 times. Why? Let's understand. First time, distance of 3. So what I'm saying is, hey listen, I am at 3. Okay, I'm at 3. So as of now I know that it's infinity, right? As of now I know this, it is infinity. So by the way, just remember the source will always have 0. The source will always have 0. Remember this. Okay, so I see infinity for the first time, distance of 3 plus 1 lesser than distance of 4. So infinity plus 1 lesser than infinity, and this is wrong, so not to be updated. Next, 2. Distance of 2 plus 2 lesser than distance of 3. Again, infinity plus 2 lesser than infinity. No, not to be updated. Next, this distance of 1 plus 1 lesser than distance of 2. Infinity plus 1 lesser than infinity. No. Next, distance of 0 plus 1. Distance of 0 plus 2 lesser than distance of 1. So this is 0 plus 2 lesser than infinity. Yes. So you'll say 0 plus 2 lesser than infinity. Yes. So what you'll do is, on the first iteration, this got updated to 2. On the first iteration, this got updated to 2. So that's the first iteration that you did. Let's do the next iteration. On the next iteration, again 3 plus not to be done, 2 plus not to be done, but this will be operated. This will be operated. Why? Distance of 1 plus 1 lesser than distance of 2. What's distance of 1? That's 2 now. 2 plus 1, that's 3. Lesser than infinity. Yes. Yes. So you will make this as 2 plus 1 as 3. Updated. Second iteration is done. Let's do the third iteration. Third iteration says not to be done, but this one will be executed. 2 plus 2. So 3 plus 2. 5. And again, if you keep on performing, these will not yield anything. So 3 iterations done. 3 iterations. Fourth iteration. On the fourth iteration, this 5 plus 1 will be lesser than infinity, and this will come as 6. So did you observe this? That on doing this, like the number of nodes were 5. So if I did 4 iterations, this is the worst case. This is the worst possible graph that I can have. I ended up this initial source. I started with source, which helped the neighboring guys. So if you think it as a graph, there will be always a source which will help the neighbors. So help the neighbor. Then those neighbors will help their neighbors. Then those neighbors will help their neighbors. Then those neighbors will help their neighbors. So ultimately expanding, right? So eventually you will end up getting the minimal distance. Understood the intuition? Yeah. So I've taken the worst case, like linear graph. If it's a very complex, easy graph, compact graph, or better ho jayega. N-1 iteration might not be required. At the worst case, N-1 iterations might be required. UQ guys. UQ guys. आया समझ में? क्या नहीं आया? कितने लोग का है? How many of you did not get it? I'll give you one once, so don't worry. But how many of you did not get it? ये नया बंदा है मयंक नया बंदा है नया बंदा है भाई. तुम बाकी लेक्चर में क्यों नहीं है? So if I write the code, then probably you will understand it much better. What I'm doing is, I am saying I'll run it for 0 n-1 times, okay? And what I did was I ran for edges, assuming I'm running on the edges, just the edges, okay? And I'm saying u is it.u, v is it.v, wt is it.wt, okay? And then I am saying if distance of to reach u plus wt is lesser than distance of v, then distance of v is equal to distance of u plus wt. And I'm doing this for n-1 time. That is what the code resembles. That is what it resembles. वह मिन फ्लो करा देते हैं और मुझे नहीं लगता आई विल गेट क्लासेस फॉर ग्राफ्स और ग्राफ्स, और ऐसे मिन फ्लो प्लेसमेंट्स पे नहीं आता, तो इट्स अ सीपी टॉपिक एंड ऑन यूट्यूब आई डोंट टीच सीपी टॉपिक्स दैट मच. दिस इज द कोड. वह मिडिल क्लास वालों को जॉब करना चाहिए, खुद का बिजनेस. व्हाट आई पर्सनली फील इज इफ यू हैव अ वेरी स्टेबल business at your home, I think you should look forward in developing that. Or probably you can work in the industry, gain some experience, and then come back to help your father. That's no problem. Like if today I have a business, तो उसके बाद कोई तो चलाएगा, right? दान तो नहीं करने वाला. Probably get some experience. Or what if you go to your father? He'll probably teach you. It's okay. There's no harm in that. But make sure don't just get into the business, because what if the business doesn't runs. पहले एजुकेटेड हो जाओ, थोड़ा एक्सपीरियंस रख लो, तो कल को अगर बिजनेस नहीं भी चलता है या फिर लाइक फॉर गॉड्स ग्रेस अगर बंद भी हो जाता है, यू स्टिल कैन गेट बैक, राइट? मतलब खुद इतने काबिल होने चाहिए कि अगर वो भी नहीं चला तो मैं कुछ तो कर ही लूँगा. एंड लोग होते हैं कि क्लास 10 भी नहीं पास करते हैं, बिजनेस शुरू कर देते हैं. बिजनेस क्या पता कल बंद हो जाए, राइट? आई हैव सीन अ लॉट ऑफ बिजनेस which ended due to this COVID, and इतने सारे बच्चे थे उन्होंने पढ़ाई नहीं किया था, तो कितना कितना दिक्कत हुआ, राइट? तो या मेक श्योर you always do that, right? Always make yourself that much capable कि even if you leave your standard job and even if you're doing something else, you can always get back. There is still a backward direction where you can get back and again start. Got it? भाई सौरभ डीपी सीरीज, मतलब क्या इंसान हूँ या रोबोट हूँ? भाई इंसान हूँ, इंसान. आई एम अ ह्यूमन बीइंग. MS, I don't think MS like, see, I'll tell you about this after this. So by the way, ये समझ में आ गया ना सबको? कितने लोग और एक बार चाहिए, फिर उस हिसाब से बोलूंगा, नहीं तो फिर रहने दूंगा. How many of you need it once more, then I'll tell it, otherwise not? How many of you need it once more, then I'll tell it, otherwise not? How many of you need it once more? MS, I'll tell MS के बारे में थोड़ा देर बाद पूछ, मैं बताता हूँ. कोई क्रिप क्या? ओके, देखो अपन ने क्या किया. अपन ने यहाँ पे एक नोड रखा था, इसका वेट सपोज 1 था, इसका 5 था, इसका 2 था, इसका 1 था. ओके, so what I did was assuming all the edges are like this, the edges are in the opposite direction, assuming the edges are in the opposite direction. ठीक है, क्विक रिकैप आर्यन बोला तो फिर मैं बोल ही देता हूँ फटाफट. देखो क्या कर रहा हूँ, मैं सारे एजेस पे n-1 टाइम चल रहा हूँ, सारे एजेस पे. ओके, ये फॉर्मूला लगा दे रहा हूँ. सो बेसिकली क्या होगा, देखो इनिशियली इसको 0 रखना, विच इज द सोर्स. दिस इज द डिस्टेंस अरे आई एम टॉकिंग अबाउट, डिस्टेंस अरे. कीप दिस इज इंफिनिटी. ठीक है, 3 इंफिनिटी है, +1 इंफिनिटी ना, 2 + 2 इंफिनिटी ना, इंफिनिटी +5 ना, 0 + 1 infinity. Yes, so 0 + 1 1. This is what I'm doing over here. Distance of u, so distance of u is 0 plus weight is 1, lesser than distance of v is infinity, so you replace. So the first iteration it got replaced, right? Again to the next iteration. So the next iteration 1 + 5 6 होगा और ये बाकी सब नहीं होंगे. Next 6 + 2 will become 8, third iteration. In the fourth iteration 8 + 1 9. It's kind of a greedy. तुम्हें पता है सोर्स 0 है, तो तुमने बोला कि इसके सारे एडजेसेंट, इसके सारे नेबर्स को मैं पहुंच जाता हूं. एक बार पहुंच गया नेबर्स के पास शॉर्टेस्ट डिस्टेंस में, अब नेबर से उनके ऊपर पहुंचता हूं तो और एक लेवल गया, अब उस नेबर से और ऊपर तो सबके पास पहुंच गए. आया लॉजिक? इंट्यूशन वाज दैट. एक छोटे से स्टार्टिंग पॉइंट से सब जगह गया, फिर उन सब जगह से बाकी सब जगह, फिर उन सब जगह से बाकी सब जगह. दैट इज व्हाट बेलमन फोर्ड थॉट. ओके, नाउ Bellman Ford thought that, but how will Bellman Ford be like okay, Bellman Ford is thinking, but how will I detect if there is a negative cycle? So ये जो distances है, I got all these distances, right? So Bellman Ford said, okay, that's absolutely correct. So, but how will I detect if there is a negative cycle? So Bellman Ford said, hey, if there is a negative cycle, it will automatically work. even after n minus 1 iterations, after that if I do one more iteration, the distance will still reduce. The distance will still reduce. So Bellman Ford said, how? How? Isn't it obvious? If you're like 1 to 2 gaya tum, okay, and 2 to 3, and 3 to back to 1, and this is a minus 1, minus 2, and minus 3. So probably this was initially 0, and 0 minus 1 this become minus 1, and then minus 1 minus 2 become minus 3, and then minus 3 become minus 6. So every time you do an iteration, it's gonna reduce only, right? So even after n minus 1 iterations, if the distance, if you do one more iteration and the distance still reduces, you can say there is a cycle. Got it? Got it? No, I did not have my dinner. I'll have my dinner. I was actually sleeping. I took a break from office today. I took a break from. आज मैंने office नहीं किया तो मैं सो गया था. उठा मैं. I just woke up at 9:50. Okay. So if after doing n minus 1 iteration, you just do one more iteration, and yeah, if there is something like this, then you can say yeah. So just quickly I'll write Bellman Ford, then I'll start with the next question. Bellman Ford. So yeah, for int, probably you can keep a distance. Assuming one based indexing, guys. N plus 1, comma infinity, which is int max. And you can say I will be doing it till n minus 1. So yeah, and then you can go across edges. And yeah, if that's the edges, so you can say int u equal to it dot u, int v equal to it dot v, int wt equal to it dot wt. And can I say if distance of u plus wt equal to distance of v, then I can say distance of v equal to a distance of u plus wt. Now at the end, just make sure you do one more iteration. Yes, at the end, just make sure you do one more iteration. Just copy paste this. Just do one more iteration. And in that iteration, yes, in that iteration, if you like, in that iteration, if you see this happening, you can probably say cout exists a cycle and return. And if it does not, then print the distances from the source, and whatever it is the distance. This is an n square algorithm, whereas a Dijkstra was n log n algorithm. This is an n square algorithm. Clear hai? Clear hai? I'll do alien dictionaries के बाद. Ankit, I'll do alien dictionary. I'm not sure वो question का है. लीड कोड का लिंक भेजना, कोई दूसरे क्लास में करवा दूंगा, ठीक है? लीड कोड का लिंक भेज देना. ऐसा मतलब तुम क्वेश्चन मुंह से बोलेगा तो क्लियर नहीं होगा ना. जस्ट गिव मी द लिंक ऑफ दैट क्वेश्चन, आई विल सॉल्व इट, ठीक है? ये यूक्यू अंडरस्टूड सोल्यूशन यूएस कुछ भी लिख दो. यूएस अंडरस्टूड सोल्यूशन. अच्छा, अब से यूएस यूज करेंगे, ठीक है? फॉर अंडरस्टूड सोल्यूशन, यूक्यू फॉर अंडरस्टूड क्वेश्चन. ओके, that will be our. Okay, so let's have this funda. So UQ whenever you understand question, UC for code, US for solution that I explain. Okay, perfect. Okay, this is what we'll do. And जब दोनों लिखना है, US UC दोनों लिख देना. Okay. हाँ, तो प्लेसमेंट इंस्टाग्राम पे उसका स्क्रीनशॉट भेज देना अंकित, ठीक है? जो भी क्वेश्चन आया था, जस्ट पिंग मी ऑन इंस्टाग्राम द क्वेश्चन, ठीक है? Okay, cool. So this is the format that we will follow. UQ for question, UC for code, US for solution. Okay. Pin abbreviations for the new one joining. Okay, cool. So next question that we will do is definitely something which is absolutely alien dictionary. Here's the question. Alien dictionary is what we will be solving. Here's the question goes. It's a lead code hard, and that will be the last problem for graphs. The entire graph, I hope जितना जरूरत है प्लेसमेंट के लिए मैंने पढ़ा दिया है. इससे ज्यादा प्लेसमेंट में नहीं पूछते हैं. ये पूरा 6 क्लास देख लोगे, इससे ज्यादा प्लेसमेंट में नहीं आता है. ओके भैया, ग्राफ्स के प्रॉब्लम में थोड़ा प्रैक्टिस करो, हो जाएगा. Vishal, just keep practicing, it'll work fine. Okay. I want to read the question. By the way, guys, is it lead code premium? I'm not sure. Is this question a lead code premium? I don't think so. I'm not sure. Check करके बताओ. मेरा वो मैंने एक बार क्रेडिट कार्ड स्वाइप करके लीड कोड प्रीमियम खरीदा था, वो उसके बाद से ना मैं उसको हटाना भूल गया. वो हर महीने पैसे कट जाता है, अब हटाना पड़ेगा. एवरी मंथ इट डिडक्ट्स मनी अनफॉर्चुनेटली. Every money just deducts money from my credit card. I have to stop it. काम हो जाता है स्ट्रीम में. स्ट्रीम करने में मजा आता है. लीड कोड you know how to find the question. लीड कोड या लीड कोड नहीं मैं हटा देता, बट फिर स्ट्रीम के टाइम बहुत दिक्कत होता है, कभी कभी मिलता नहीं है क्वेश्चन. तो मैंने सोचा कि ठीक है स्ट्रीम करता हूँ तो रहने देता है. जीएफजी में मत चेक करो यार, टेस्ट केसेस गलत होता है. ये और चेक कर लो वाले. जीएफजी में बहुत टेस्ट केसेस का इशू है. व्हेन आई मेड द ग्राफ सीरीज, मतलब टेस्ट केसेस गलत है यार. लोग मेरे को बोलते तुम्हारा ग्राफ का कोड गलत है. एंड दे प्रॉब्ली 0 बेस्ड इंडेक्सिंग 1 बेस्ड इंडेक्सिंग दोनों डाल दिए एक तो किसी क्वेश्चन में, साइकिल डिटेक्शन में. एंड पीपल आर लाइक मेरे वीडियो में कमेंट करें आपका कोड गलत है, जबकि जीएफजी में टेस्ट केसेस गलत है. कमेंट्स अगर देख लोगे पता चल जाएगा. गूगल आस्क क्वेश्चन भेज दो. इसमें क्या भेजना है यार, मतलब read the question. will start after 11:49 is when I'll start. I'll give you 3 minutes. I'll tell you about MS. Someone was asking me about MS. So basically देखो MS, see what are when should you do MS? Let's understand. If you are aspiring for doing some like aspiring for higher studies, like your aspiration is higher studies, more research. If you're a candidate who wants to study more and more, he wants to know about stuffs more, he wants to do a lot of research, then it makes sense. But if you're someone who is like, I need better placements, then MS is not for you. Why? फिर मैं स्क्रीन भूल जाता हूँ, ये मेरा ना अलग ही आदत हो गया है. See, if you're aspiring for higher studies, and more research, MS is for you. Okay. If you need better placements, then you don't get anything better. Like whatever you can get via BTech, like what do you get? For an example, let's take Amazon. You get an Amazon SD1, right? So even if you do an MS, the only difference will be you will get an Amazon SD1 in US. It won't be they will give you SD2. It's not gonna happen. Google SD1, they're gonna give you same post which a BTech graduate gets. The only difference is you'll get a job at US. Okay, but what are the consequences? So if you're doing an MS, you'll end up spending around 30 lakh, 40 lakh. That's for 2 years around. You'll end up spending 30-40 lakhs. And a lot of time, yeah, you do recover that while you get a job. But see, after BTech, like if you're just solely doing it for placement purpose, after BTech, you spend 2 years for MS. Alright, so that's a 2 years wastage that you're doing, because probably you could have just started working after BTech, and that's a 2 year wastage. Like just if you're looking for placements, 2 years is extra, and then another 2 to 3 years in order to have the depth of 30-40 lakhs, that loan that you have taken, you have to again repay that. So another 2 to 3 years you're gonna spend in like taking that loan off, right? And फिर उसके बाद तो 4 साल हो गए तुम्हारे. और इन 4 साल में एक जो BTech graduate who was like, for an example, I am a BTech graduate. In these 4 years, I will probably be an SDE2 who will be earning the same salary that you are starting off as of now in US. I'm still in India. Well, I can get an international offer. So if you want to go in international, work for 1 year in India as a BTech graduate. After that, really after 1 year, try international, you'll get the international packages. For that, why do you need to do an MS by taking a 30-40 lakh loan? Does it make sense? Unless until you're aspiring to do higher studies. Right? मतलब US जाना है तो ठीक है ना, बीटेक के बाद जॉब करो, 1 year एक्सपीरियंस ले लो, 1 year of experience, and then apply internationally, apply Europe, apply US. You will get shortlisted, you will get calls, and then give the interviews, crack it, So instead of actually taking an MS route and spending 30-40 lakhs, which absolutely will give you the same job, like, I don't see a कुछ मुझे तो प्रॉफिट नहीं दिख रहा है, क्योंकि ये देखो ये वाला चीज ठीक है. इफ यू आर समवन हु इज वेरी विलिंग टू गेट इनटू समथिंग, there are people I know who get into these things, they want better, higher studies, more research, then it's okay. Or if you have a lot of money in your home, like पापा को फर्क ही नहीं पड़ता तुम कितना कमा रहे हो, तो चले आओ, बहुत अच्छे प्लेसमेंट्स मिलेंगे. बट इफ योर होम इज नॉट फाइनेंशियली स्टेबल, there's no point in taking 30 lakh loan if your home is not financial. जो एमएस के लिए जीआरई का मेहनत करोगे, फिर अगर तुमको वही एमएस मतलब कंप्यूटर साइंस में ही करना है, डीएसएल को तो पढ़ना ही पड़ेगा. ये तो तुम एमएस कर लोगे ना कंप्यूटर साइंस में, सीएस में, लेट्स से सीएस में, फिर तुमको वही अमेज़न एसडी डीएसए पढ़ना ही पड़ेगा. तो भाई बीटेक में ही पढ़ लो ना डीएसए, स्टडी बीटेक में ना डीएसए, और इधर से ही जॉब ले लो. क्यों जाना है 30-40 लाख, समझ में आया? और ये एक जो लोग बोलते हैं ना 1 करोड़ में, मतलब 1 करोड़ पैकेज, यार क्या मतलब है 1 करोड़ पैकेज का यूएसए में? क्या है 1 करोड़ का पैकेज? इन दिस 1 करोड़ पैकेज whatever you get base as 70-60 बेस देता है Amazon SD1 को, 60-70, which is roughly around 5 lakh per month. टैक्स डिडक्ट होके I guess it will be around 3 lakh something. इस 3 लाख में तो 1.5 लाख तो तुम्हारा रेंट है, 1.5 lakh is rent, 50k is around your expenses. You just left off with 1 lakh. Yeah, I understand you'll get to save a lot, but still, if you're staying in USA, you have to have a very luxurious life. You can't be like फटा जीन्स पहन के घूम रहे हो. तो वहां रह रहे हो तो तुम्हारे खर्चे भी वैसे होगा. तुम फटा घर में, छोटा सा घर में नहीं रहोगे यूएस में जब रह रहे हो. यू आर एन Amazon SD1 और Microsoft SD1 और whatsoever SD1, you will bump up your lifestyle. So वो जो 70 बेस होगा ना, वो कमी नॉर्मल स्टैंडर्ड लगेगा उधर के हिसाब से. अब जब यूएस में रह रहे हो, इंडिया तो आओगे नहीं, उधर घर खरीदना होगा, जिंदगी में नहीं ले सकते. अब क्या बोलेगा, उधर जॉब करूंगा इधर घर लूंगा, क्या मतलब है? लॉजिकली अगर सेंसिबली सोचोगे, पैकेज अच्छा है, but can you settle down with that package over there? No. Simple as that. India, can you settle down with this package? Yes. So काफी चीज है. अगर कमाना है 10 साल के लिए जाके, मतलब if you are planning like 10 साल के लिए बहुत पैसे कमा के इंडिया आना है, तो ठीक है, तो कर सकते हो. That's okay. Right? Yes, पे सड़क पे. If you want to, as I said ना, see, if your aim is higher studies and more research, you go. But if your aim is just for placements, don't go. If your aim is just for placements, there's absolutely no need to invest 30 lakhs. Your aim should be मुझे और पढ़ना है, मुझे और सीखना है इस फील्ड के बारे में, तब जाओ. ऐसे प्लेसमेंट्स और चाहिए तो कोई मतलब नहीं है. बीटेक करके लो ना यार. गॉट इट? क्लियर है सबको ये वाला पढ़ना? अच्छा, 101 वॉचिंग आ गया. मैं ये बकवास कर रहा हूँ तो अच्छा चीज पढ़ा हूँ तो 101 वॉचिंग नहीं आएगा. सही है भाई. Anyways, question please. Clear है सबको? Problems करो तब. Okay, understood question. Understood the question. ठीक है अंकित, चेक कर लूंगा. इंस्टा पे भेजा है ना? हाँ. इसमें भेजा है भाई, 1 सेकंड. कहाँ है भाई? अंकित कुमार सेंटर फोटो. और भाई इतना सारा फोटो क्यों भेज दिया भाई? भाई काम करना, एक डॉग कुछ भेज दे, डॉग का लिंक भेज दे. एक जगह सारा फोटो डाल के डॉग. ये इंस्टाग्राम पे मुझे समझ नहीं आ रहा कौन सा फोटो पहले देखो. ठीक है भाई, ये कर दे, डॉग का लिंक, एक ही क्वेश्चन को डॉग के लिंक में डाल के भेज दे. ठीक है, वो बेटर रहेगा तो मैं इजीली देख पाऊँ. स्ट्राइवर शॉर्ट्स पे आ जाएगा. हाँ ये पका. मतलब छोड़ो यार, मैं तो डर के आजकल कुछ बोलता नहीं हूँ. कोई शॉर्ट बना के डाल देता है भाई ना, मैं नहीं बोलने वाला और कुछ. ठीक है. Okay, let's understand the question. So question says alien dictionary. Okay. Question says alien dictionary. Screen change कर रहा हूँ, रुको. Let me just write this. WRT WRF ERETT RFTT. Okay. What's the question? The question says there is a new alien language that uses the English alphabet. However, the order among letters is unknown to you. Like generally, the order is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P till Z. But over here the order is unknown to you. Okay? You are given a list of string words from the alien language dictionary, where the strings in words are sorted lexicographically. So they are saying that whatever words they have given you, sorry, is lexicographically sorted. I'll be like, okay. Now you have to return a string of unique letters in the new alien language, such that it's in the lexicographically increasing order. Return empty if it's not possible. If there are multiple answers, you can return any of them. Okay. Now let's understand kya funda hai. So I'm saying this is the lexicographical sorted order. I'm saying this is the lexicographical sorted order. Okay. So if this is the order, as of now, W is the first guy. W is the first guy. Like normal English alphabet would have been A, B, C, D something. But over here, which is the first guy? W. I know W is the first guy. Now what's the next guy? After W, who is coming? E. So can I say W is definitely the first guy. But what about the other thing? Like over the answer is given, so answer ही लिख के मैं समझा देता हूँ. WERTF. Okay. WERTF. Let's understand. These two strings are sorted in lexicographical order because T is smaller than F. So according to them, in the alien language, not in the ABCD language, in the alien language, T comes before F. So T is coming before F. Absolutely okay. Next, these two guys are differentiated by W and E, stating that W comes before E. Again, in the alien language, W comes before E. Next, these two guys are separated by saying that R comes before T. R comes before T. Next, these two guys are lexicographically sorted by saying that E comes before R. So E comes before R. So can I say according to the alien language, like if I do not consider the generic language, the alien language WERTF will say that this is lexicographically sorted. Do you agree? Do you agree? अगर मैं ये वाला alien language दूं ABCD के जगह, can I say these are lexicographical sorted? Can I say these are lexicographically sorted? I mean, if you agree. I mean, if you agree. मान लो पहले मेरा ग्राफ सीरीज देख लो, फिर ये वाला सारा देख लो, तो प्रॉब्लम सॉल्व हो जाएगा. ठीक है, रिवाइज हो जाएगा ये फटाफट. UQ, understood the question? Have you understood the question? Agreed? Okay. Let me give you one more example. By the way, ये पूरा जो लिस्ट, ये जो पूरा लिंक है PDF का मैं दे दूंगा. ठीक है, ये देखो Z and X है. So there are two strings. So XZ should be there. XZ should be there. Now there is a ZXZ. So is this possible? Is this possible? Is this practically possible? ये प्रोग्रामिंग इन सी फिर आ गया रात को. ये कल भी आया था. कौन सा सस्ता नशा करता है भाई? ओके, cycle, right? Yeah. Z comes before X and X comes before Z. So how can you do this, right? How can you do this? I think ये रात को क्या करता है? ये रात को 12 बजे नशा करता है एंड फिर स्ट्रीम में आ जाता है. अच्छा, सब्सक्राइब ब्लॉक नहीं करना, सब्सक्राइब किया है ना, सब्सक्राइबर बढ़ रहे अपने, क्या जा रहा है? मेरे तो नहीं बढ़ रहा, बट ठीक है, कोई बात नहीं, सह लेंगे. Okay, so how will you do this? Let's understand the question. How will you do this? So generically, don't you think if I can create this into a topo sort, the answer will be done? Don't you think if I create this into a topo sort, the answer will be done? Like if I consider these two guys, where are they differentiating? If I consider these two guys, where are they differentiating? Can you tell me where are they differentiating? They're being differentiated at T and F. So can I say I can create a directed graph between T and F? Can I say I can create a directed graph between T and F? I can. Thank you, programming in C. Okay, T and F, right? Next, over here, where are they getting differentiated? For which? Where are they getting differentiated? Can you tell me? W, R, F and ER. किसके वजह से they are sorted in this way? Where are they getting differentiated? Can you tell me? Where are they getting differentiated? Come on, quick. Yes, W and E. So that means there is a directed graph between W and E. Right? There's between W and E. Okay. Where is this getting differentiated? R and T. R and T. It's getting differentiated between R and T. So R and T. R and T. Right? First non-matching character. Where is this getting differentiated? U and E and R. E and R. So if I just connect this, it will be like this. Now over here it got connected. Over here it got connected. So how do I make sure? How do I make sure to create a linear ordering of vertices? Linear ordering of vertices, because that is what they want. They want the linear ordering. How do I create a linear ordering of vertices such that if there is an edge between E and V, U comes before V in the linear ordering? What is this known as? यही तो चाहिए ना, WERTF. यही तो चाहिए WERTF. कैसे करेंगे? कौन सा ऑर्डरिंग विल मेक श्योर? No, this is ये कुछ क्या था, ये मुझे पता नहीं. ये कुछ तो था, ये दूसरा चीज था. ये RFTT था. This is RFTT. So E and R will get connected. Topological sort. Yes. So can I say if I can find mismatches on every pair, if I can find mismatches on every pair and then create a DG and then create a directed graph, the topo sort will be the alien language. The topo sort will be the alien language. Can I say? How many of you agree? How many of you agree? US understood solution. What's the edge case? What's the edge case? What is the edge case? Something like there are some edge cases you have to be very careful. What are the edge cases that I can think of? What if I have like Raja and Raj and Rama? Okay, if I have something like this, can you tell me what will be the alien language? Can you tell me what will be the yes Mihir, yes. Can you tell me what will be the alien language for this? इसका alien language बता सकते हो क्या होगा? Can you tell me what will be the alien language for this? Can you tell me what will be the alien language for me? For this? It's invalid. Why? Because these two guys matching. So matching. They're already matching in the first three characters. So if they are not mismatching, so this longer guy should have been after Raj. So one of the things that I figure out, one of the edge cases is if no mismatch, then longer has to be after shorter. Agreed? That's the first thing that I can think of. Okay, absolutely perfect. Okay. What is the next thing that I can think of? The next thing that I can think of is, what if I have something like RAG, RAM, SAR, no, SAR, SRC. Okay, if I have this, so apparently what I'm saying is on this first J and M, on this first J and M, right? So J and M, on these next two R and S, on these next two R and S, and on these last two A and R, this is still valid. This is still valid. This is still valid, right? But what if I do a change and I make this guy S? In that case, what will happen? In that case, what will happen? There was an R and S, there was an R and S, and due to the last, there is like S and R, there is like S and R, so S and R. So it formed a cycle. So you cannot create an alien language. You cannot create an alien language. So for this, it's not possible. So the edge cases are basically if there is no mismatch and the length is longer, and the second edge case is cycle, if there is a cycle in DG, because we know toposort is only possible for DAG, because we know toposort is only possible for directed acyclic graph. Does that make sense? Does that make sense? Have you understood the solution? Create a DAG, print the toposort, that's the answer. Create a DAG, print the toposort, that's the answer. Clear है? Clear हो गया सबको? Clear है सबको? Yes or no? Has everyone understood this? Yes, yes. US, everyone? Okay, so everyone remembers the abbreviations, isn't it? Okay. So, should I code? कोड करूं रात को ऐसे? एक तो बजा नहीं अभी तक, है कि नहीं? कोड करें? Brother, why are you wasting your time here? Go and build startup like Coding Ninja, sell your competitive programming course. Course तो मेरा अभी भी चलता है. See, it's a love that people watch my life. मेरे पास इतने free content है, तब भी मेरे पास लोग पैसे देके पढ़ने आते हैं. So I don't need to create any startup. People still come up. That's okay. कितने स्टार्टअप बनाओगे यार? इतना एडटेक बना के क्या होगा? जितना है उतने में ही चला लेते हैं, है कि नहीं? क्या करोगे इतना बना के, है कि नहीं? इतना टाइम भी नहीं है, to be very honest. Okay, cool. So I have like words dot size. So what I need is I definitely need something like an adjacency list. That is something I definitely need, right? So probably I can keep like vector of int and adjacency of n plus 1. So what is the, but before that, learn memory management. Programming in C, can you please teach me? I'll be very glad अगर तुम मुझे पढ़ा दोगे, है कि नहीं? है कि नहीं? I'll be very glad if you can teach me. Anyways, so can you tell me the DAG that you will create? It's clearly written that it will only have lowercase English letters. So the DAG that you will create, assuming you say A to be 0, B to be 1, C to be 2, D to be 3. So can I say it will be of 26? Can I say it will be of 26? Right? Because 26 letters, assuming to be 26. Right? Perfect. So we've done this. Now what I'll do is probably I can write a private function which gives me int get int char c, and I'll say return c minus a. Yeah, so I've written this. Perfect. Now what I'll do is let's create the int 0 equal to I less than n minus 1 I plus plus. I know string s1 will be words I, and string s2 will be words. ये मैंने सबमिट किया है क्या? ये भी मैंने सबमिट किया. 2019. It's been long. I submitted this problem. I plus 1. For now, you can start comparing them. Yes, you can start comparing them. And I know for sure one thing. I'm not comparing like j lesser than, probably I can have the int m equal to s1 dot size and j lesser than m, j plus plus. So while I'm comparing, if the j is exceeding the s2 dot size, just in case the j is exceeding s2 dot size, then there means that does not exist. That means that does not exist certain kind of thing. So I'll return the answer. I'll say no, it's not possible. It's practically not possible. And they have clearly said that you need to return empty if there is no solution. So if I'm comparing and the j exceeds the size, there is nothing to compare, like Raja and Raj. This is the example of Raja and Raj. Okay, Raja and Raj, you have compared Raj, and then on the a, whenever your j is over here, you don't find anything to be compared with s2, so you can return. Okay, or if s1 of j is not equal to s2 of j, we can create a DAG, and the DAG will be a get integer of s1j. Okay, so s1 को पहले आना होगा j से, s1 को पहले आना होगा j से, तो s1 से लूप बनेगा इधर तक, s2 of j. Okay, don't you think this will be it? So I will create a DAG, and the moment you've created a DAG, there is no need to, only the first mismatch is what you need. Only the first mismatch is what you need. So I have done this. So once I've taken this, I just need to check if there is a cycle. If cycle check on DFS, if cycle check on probably DFS, if I'm saying a cycle check on DFS is true, like I can probably start from the first node, and there are multiple nodes, right? There are multiple nodes. So what can I do? I can probably say, okay, let's do one thing. Let's keep a vector of int which votes are there, like which votes are there, because I only need those votes, right? Vector of int votes, and probably I can keep a vector of int of visited also, visited 26. So probably over here I can say the word that are in the DAG, are s1 of j, sorry, get int s1 of j equal to 1. The words, पहले समझ में आ रहा है ना, यहाँ से समझ में आ रहा है, हाँ ना, यस लिख दो तो फिर मैं भी थोड़ा कॉन्फिडेंट हो जाऊंगा. So I have made sure that the words is already defined. Okay, I'll take present, and while I say present, yeah, they are present. So I will call the cycle check. Now I know the words that are present will be called for cycle check. So I'll go like this, and I'll be like, if it's present, and it's still unvisited, let's call the DFS to check for cycle, check cycle, and check cycle DFS probably. Okay, check cycle of this node I, and adjacent you can take it, and you can take the visited as well. So if the check cycle is true, you can definitely return an empty string, or else at the end of the day you need to return the string. So probably string answer equal to this, and over here what you can do is you can probably have the stack, which will also be used to create the topo sort, and you can also pass the stack over here. And what you can do is you can probably run across the stack while stack not empty, and if like answer plus equal to character st.top plus whatever a is, and then st.pop, and then you can return answer. I think, yeah, that should work fine. That will work fine. And okay, now I have to write cycle check private, and I'll write check cycle, boolean check cycle int node. int node चाहिए, adjacent चाहिए, so अपन ले लेंगे adjacent, vector of adjacent Next, it's a vector of adjacent. Next, I need just the visited. So I'll take vector of int and visited, and I'll take stack of int and an entire stack. And now what I'll say is, okay, hey, listen, this is visited. Okay, so I'll be like, this is visited. Perfect. Let's go across the adjacent nodes. Perfect. And let's see if it's not visited. Okay, if it's not visited, hey, why don't you call the DFS for cycle check cycle, and I'll call it for IT. I'll pass on the adjacent, I'll pass on the visit, I'll pass on the stack, and if this returns a true saying it has a cycle, I will return a true saying it has a cycle. Okay, if it doesn't return true, it's okay. Else if even after getting visited, like if it's visited, okay, I need to carry a path visit also. In order to check in DJ, I need to carry a path visit also. I have to carry a path visit also. So else if the path visit is also true of this particular IT, then I can say it's a cycle. Okay, and over here I can probably do a path visit of node. Okay, a path visit of node equal to 1, and probably I can do path visit of node equal to 0, and I can return a false saying that it does not have a cycle. And I can also create one more path visit. Oh, by the way, 26, 0, 26, 0, and path visit will also be 26, 0. Okay, so this is how it looks like, and probably I can also pass in the path visit after this. I'm not sure, I'm written a very big code. I say this works. Okay, let's see if this works. Okay, wrong answer. Okay, amazing. We got a wrong answer. That's amazing. Where did we get the wrong answer? Let's see. Did it break it over here, or did it break other way? Did it break here, or did it break other way? Anywhere else? It did not break here, that's for sure. So it did detect a cycle, which is wrong. It should not have detected a cycle. Let's see. Why did it detect a cycle? Visit of node equal to 1, path visit node 1. So if this is true, visit path visit अगर 1 है, let's first see if the graph is properly created. I doubt if the graph is first properly created or not. स्टैक तो यूज ही नहीं किया ना, इसीलिए. Good, thank you. I did not use the stack only. Goodness gracious me. I did not use the stack only. I'm so great. I'm so great. एक बार में कोड लिख देता मैं तो. We did not come up with a mismatch. Okay. Oh, we did not figure this out. If the size इसमें empty क्यों होगा? ये तो सही है यार. ये तो सही है. Expected Z. अच्छा. Expected Z है. Okay. If it is same, if all the numbers are same, then what will happen? Okay, so ये वाला अच्छा case था. This edge case we missed. This is an edge case that we missed. Okay, so probably you can keep a flag over here. Flag equal to 1. Flag equal to 1 रख सकते हैं. यहाँ पे flag equal to false रख देते हैं. So in case flag comes out to be 0 after this, in case flag comes out to be 0, which means present the first guy को ले लेते हैं. फर्स्ट गाय को ले लेते हैं एंड बोलते हैं भाई तू है. चलो Coordinate programming in C you should solve, isn't it? Okay, we come up with another wrong answer. Expected y x z. भाई क्वेश्चन हम लोग गलत समझे क्या? Z y z x should be only y x. Okay, they are also wanting all these guys which are present. Okay, they are also wanting all of these guys that are present. So okay, that makes sense. So yeah, just make sure you mark all those present. They're basically wanting all the guys that are also present. Okay, not an issue, let's do s1 of z equal to 1. Okay, that will do. They're also wanting all the guys that are present. So yeah, basically they are wanting all the guys that are present. अब क्या प्रॉब्लम है इसको? एक्सपेक्टेड बीडी है, अच्छा ब्रेकआउट हो जाएगा तो फिर नहीं लेना है। ओ भाई साहब, ओ भाई साहब, भाई साहब, भाई साहब, भाई साहब, भाई साहब, एक काम करो, एक काम करते हैं, तो इसको हटा के एक और एक लूप चला दो इसके बाद, एंड बोलो भाई ये बंदे प्रेजेंट है, इन सबको पहले तुम प्रेजेंट में ले लो। इससे पहले एक लूप चला दो, I and I equal to 0, I lesser than n, I plus plus, and just make sure auto of it equal to s of words of I, and say present get int it equal to 1. I think that should work now. Yeah, works fine now. Cool. I think that works fine. Perfect. Okay. So yeah, they basically want जो वर्ड्स है वो सब भी रहने चाहिए, अपने सिर्फ जिस पे बेस्ड है वो कर रहे थे. So they basically want all the words that are possible. अबे ऑप्टिमाइज क्यों करना है? ये ऑप्टिमाइज नहीं होगा, ये ऑप्टिमाइज्ड ही है. This is the optimized यार. This is the optimized one. Okay, by the way, did you understand this? A quick question, did you understand this? That's a quick question, did you understand this? Got it, everyone? So in short, if I just give you a quick recap, this is check for cycle, simple check for cycle, and this is just in character. What I did was I basically told ki ye words have, these words are present, so I marked it over here. Then I just figured out what's the first unmatching character is. I just figured out which is the first unmatching character, and I just created an edge over here. And after that, if there is a cycle, I said no, it's wrong, right? At the same time, I created the topo sort. And after that we can just print the topo sort, as simple as that. ठीक है? प्रोग्रामिंग इन से यू विल नॉट अंडरस्टैंड, दिमाग चाहिए होता है, तुम्हारे पास नहीं है तो तुम नहीं समझेगा. इसे समझने के लिए थोड़ा हाई क्लास दिमाग चाहिए होता है, थोड़ा कम है तेरे में, है कि नहीं? एनीवेज किडिंग, थोड़ा सा आगे जाके देख लेना, समझ में आ जाएगा. ठीक है, तुमने बीच में ज्वाइन करके परेशान करना शुरू किया, तो तुमने अब बीच से ज्वाइन करके परेशान किया, तो पहले का तो समझा ही नहीं ना, पहले जाके समझ लेना, आ जाएगा. Okay, clear? Okay, so I'll just copy paste this and give you the ID1 code for this. So yeah, we wrote across 1,000 lines code in the entire okay, I recorded. Put in shots, tag me in shots. You make shots, I get promoted free में, मेरा promotion हो जाता free का. बनाते हो, मुझे क्या जा रहा है, मेरा इतना टाइम नहीं है भाई शॉर्ट्स बनाने का. तुम लोग ही प्रमोशन फ्री में कर रहे हो, करो. अब नहीं बनाएगा, देखिए शॉर्ट्स. भैया मैंने तो वो खान से किया था, नॉर्मल क्यू से हुआ नहीं. पीक्यू लगाना पड़ा. पीक्यू क्यों लगाना है? सो जस्ट शेयर दिस अक्रॉस बाय द वे. अरे ये कहाँ गए? अच्छा ये ID1 से दे देता हूँ मैं. I'll give you on the ID1. Okay, this is the link. Try to open this. This is the entire code link, guys. This is the entire code link of this entire graph playlist. Entire graph का सारे codes इसमें मिल जाएगा. Try opening this BZS32Y. Can you open this? Can you just quickly confirm if you can open this entire stuff? And the PDF, I'll be putting the drive link within couple of days. The team is in off. Monday आएंगे तो मैं Monday drive link. ये जो notes है ना, ये जो notes है पूरे notes का drive link भी दे दूंगा, ठीक है? 100 पेज पढ़ाया है, 100 पेज 1000 लाइन्स. कांसाल को पढ़ाया तो था कल पढ़ाया था ना कांसाल को, टोपोसॉट के दिन L3. In L3 I've taught lecture 3. जाते जाते नोट टेकिंग SW बताते हैं. अब भाई ऑफ टॉपिक क्वेश्चन भैया, नॉन सी एस्पिरेंट स्टूडेंट्स को क्या करना चाहिए बाद में बताऊंगा यार, कल बताऊंगा. कल मिलते हैं कल. अब बहुत टाइम हो गया यार, 2 घंटा 25 मिनट हो गए. सो गाइस बाय बाय, टेक केयर. दैट वाज अ वंडरफुल ग्राफ सीरीज. So just if you enjoyed this entire 6 lectures, please do share this across. And yeah, कभी भी placements लगे तो याद कर लेना. अगर कहीं से भी help वगैरह मिलता है तो make sure you remember me, because it takes a lot of effort to create these kind of contents, and the more you appreciate, the more I'll keep on making these kind of content more and more till I survive. ठीक है, चलो guys, bye bye. I hope you enjoyed everything in the graph series, and that is it for the graph. You can watch the entire graph series if you want it in quick and take you forward. Over here you will get a lot of problems, so you can watch problems for here. Okay, bye bye, good night, take care. Tomorrow will be a mock coding round, mock coding interview. Again, an interesting question I'll bring. I'll give it to someone who can solve it probably. Let's see.